lite glapp i den här kanske. Nej. Jag fattar inte varför det glappade eller klappade eller... Det var inget bra att göra såna här ljud. Ja, men det låter i alla fall. Det låter väl hyfsat bra det här tycker jag. 1, 2, 1, 2. Är du nöjd så?
Good morning, everybody. Yeah, but the program says opening here, and looks like I'm going to talk long-winded and for 30 minutes until the real program starts, but I will not be keeping you for long. I just want to thank everybody for all the volunteer help we had yesterday. It was really nice to see that so many of the attendees like to chip in when they can. And I want to just tell that I'm sorry for Swedish beer prices and wine prices. I'm sure they shocked you a lot. There's two things in Sweden that are extra expensive, and that's basically having someone do work, which I think comes from that we like to fika a lot, which is taking coffee breaks. We take them very seriously. And then there's the alcohol, which makes it a really bad combination if you say to someone, could I please have another beer, because that involves both of those things. But for all of you that was on the social event yesterday, I thought it was really nice. I hope you had a good time. I wasn't really prepared for that. The movie was showing us how fish are dying, and then we were served fish afterwards. That was probably not the best combination, but there you go. Sometimes stuff doesn't work out exactly as planned. I hope you will have a equally good experience today as you had yesterday, and I will not keep you here any longer. The real talk starts at 9:30, and welcome once more to Sweden and EuroBSDCon 2015. Bye.
one of the testers for Lenovo.
I can qualify this project. It's an older thing, so
Your laptop
there
crashed.
won't be a hole in the
It fell to the floor.
So actually, the question is the floor okay? I couldn't.
So yeah, it's too rough to drive home. So he found this raccoon that was wandering around. And squeezed it to blow into the breathalyzer. No, this caused the raccoon to pass out. Squeezed it so hard, right? So he just like threw it in the passenger seat and proceeded to drive. At some point, the raccoon regained consciousness.
I decided to get like this. Yeah.
Car crashed into a
Use the
passenger.
restroom. One of the things I learned, always use the restroom.
Yeah, but you bite the
Before going to the bathroom.
Yeah.
I mean, it's creative, and I admire the.
Japanese ones have a better design. They got it. Although, surprised. There's more legroom in Japan, which is really surprised. Although after that IMAX theater, I don't know, those Swedish just like twisting themselves in pretzels or what?
The problem is, I mean, some sense that they will go for laptops with complex desktop. The thing is, the paper here is right here, so it doesn't say. There's no brand here. You know, so it's just cramping the size.
That's actually for me. Minute overtime.
Oh, you're running over time, buddy.
Catch!
Catch, yeah.
You don't need
I'm pretty good at tracking it, but if I'm getting within 5 minutes or so, it's a really good thing to let me know. Yeah, if I'm not doing that, that's definitely a thing where you just yell out.
Go.
You don't have to wave or anything. Yeah, see, now the other one, this would have been full. Here it looks empty.
The name came from John. You're sitting beside me. So John, the hard CSV guy on Tom mentioned that all they had to do now was actually by the Wolverine and have go. So yeah, the demo would work when we did it live in the old system. And after a while, I got nominated for it. So yes, that's the point that we're doing all
Because you got, yeah, it was the version 7 file system, so it was Their free list was just a linked list of all the blocks. It was a linked list on the disk of the blocks. Well, not quite. They had sort of an indirect block. It was like blocks. So it's a chain linked with indirect blocks. But what would happen is, of course, there's a linked list. You just get whatever order was on the list. We can put it in a bowl. So one of the disk manufacturers described it as the thin film effect. He said, all the free blocks are close to the surface of the disk. You get like 3 or 4 blocks in a file, but it'd be like one is here and one is there and one is back here. Absolutely horrendous. I mean, it started out because they were contiguous, but they didn't stay that way for very long. These files got created. The biggest tech for the file system is we got a bitmap of blocks that look around the blocks.
It goes to pretty much every company. Yes, it should fly more than that. The thing we didn't manage to do
Look kind of weird the way it sort of wraps around and sticks out. Too much speed. Okay. I was just wondering whether the mute button would actually mute, but it doesn't.
Test, test. Yep, works. Good morning. Good morning to the first session today. And the 4.1b release of the BSD operating system, the fast file system, was introduced. And that was in 1982. That's more than 30 years ago. And still, up today, the fast file system is the file system in all of the BSDs. And if you find a disk today which has still that's from that time, you can still hook it up to your computer and read the files on it. That's what backwards compatibility is. It's my pleasure to introduce to you Marshall Kirk McCusick, the author of the fast file system. Please, Kirk.
Yes. Thank you very much. You know, if you had told me 33 years ago that I would be standing up in front of an audience and explaining about some software I had written at the time, I would have said, you know, I think you're on window pane, which was a very popular version of acid in Berkeley at that time. So it is actually rather surprising to me because, you know, if you sort of look at the half-life of software, it's on the order of a few years, and so this one is, you know, 14 standard deviations out from that, and it's just utterly incomprehensible to me that it's still being used. All right, but it is, and so we're here, and I'm going to give you a history of it. And so let's just start at the very beginning. This is actually predating that file system, 1979. What was happening in 1979? We were having an oil crisis. Jimmy Carter was president of the United States and about to lose to Ronald Reagan, and it was downhill ever since. But hopefully with file systems, that's not the case. So we had the original version 6 file system at that time. That was the original file system that was written by Ken Thompson with the original Unix. And it was simple, a very small bit of code. I think it was something on the order of 400 lines of code in the complete implementation. The problem was that it didn't really have this notion of maintaining the meta information, and so it was possible that you could crash and not be able to recover it. I mean, we didn't have advanced things like FSCK at that time. It was all ncheck, dcheck, and icheck, which was one of the pieces that ultimately became FSCK. But the administrator, after a crash, had to run those things and patch the file system back into operational state. The main tool you had to do that with was a program called ClearEye, which just basically said, go smash this vnode to be 0, or inode to be 0, and you know, that'll, when you do that to enough of them, then hopefully things will get back into a usable state. So the first things that we did was staging the modifications, which is to say adding synchronous writes at key places so that the file system would stay consistent. And also in that era, the very first versions of FSCK started to come out. They were far more primitive than what you have today. It was really just to sort of automate icheck, ncheck, and dcheck, but you still had to physically sit there and answer questions about what to do as it went along. There wasn't this notion that it would just fix it all for you. All right, well, so that's sort of where I was starting from, and it actually started out because I needed a summer job. The real issue was that both Bill and I were students of the same professor, Professor Susan Graham, and we were both doing programming languages. That's what we were both doing our PhDs on, which you might find hard to believe when Bill wrote Seashell, but never mind. Anyway, Professor Graham was an excellent researcher, but she had that sort of professor absent-mindedness where some things didn't really get to the top of the plate when they should have. And so when you're a student at Berkeley and you have a grant, you only work for 49.5% time, because if they paid you half time, then they'd have to give you benefits. So, but 49.5% time, you're below that threshold. And you do that for 9 months of the year. But then in the summer, for 89 days, you're allowed to work at full time, because if it was 90 days, then you see where we're going here. But what ends up happening is that your bank account's going down, 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 and then finally you get to the month of June, where the first 2 weeks you're being paid half-time and the second 2 weeks you're being paid full-time. So you expect that three-quarter time paycheck to come in. And it's good because you've been on fumes for at least a month or so. So anyway, I get my check at the end of June, and it's not 3/4 time, it's 1/4 time. And I'm like, oh, they didn't know I was going to be here for the summer, so I go over to the place where they deal with that stuff, and they look at it and they go, oh, yeah, we see that you are, but your advisor hasn't given us the magic number that, the account at which we were supposed to charge that. As soon as she gets that to us, we can get that money to you in a day or two. So, great, I go back and go into our office and I say, oh, they need the number for your the money that you're doing in the summer. Oh, she says, I forgot to renew that. Oh, it'll only take a month or two. I'm like, So anyway, Bill at this point had gotten kind of bored with programming languages. He got bored with anything after about 2 or 3 years. So he moved on to operating systems and had gotten all excited about this Unix thing and had been part of this DARPA grant that had come in. And the DARPA grant had money for student stuff. And so I went down and I said, Bill, our advisor, I explained the story. And, could you just give me something to do for the summer? And you and I both know that I'm really just going to be doing my regular, mostly working on my thesis, but, just some little make-work project or something so that you can pay me. And he goes, oh, yeah, I understand how that works. Yeah, no problem. I'll just put you on here, And, I've got this, I've sketched out this idea for a file system, so maybe you could just, fill it out a little bit, Well, you know where that's going to lead to. So we get to the end of the summer, and I've done nothing but write the file system all summer long. I haven't got a lick of work done on my thesis. And I have a prototype that's working, and we try it out, and he goes, wow, that is so cool. Wouldn't you like to see that used by, more than just a research project, Just a little more work on this, and we could just put this in as part of our production system. I'm thinking, oh, well, that sounds pretty good. What he didn't say was, well, let's see, you got to write ncheck, dcheck, icheck, fsck, dump, restore, et cetera, et cetera. So 18 months later, I actually had something that I was willing to put my home directory on. All right, well, I've gotten a little diverted here. Before we did that, we wanted to do some things to try and understand the parameters that we should use for the new file system. And so we're trying to understand how much of the crappy behavior, it wasn't crappy in terms of reliability, but it only could utilize about 3 to 5% of the bandwidth of the disk. And the understanding, at the time, disk was so much faster than the CPUs, that was kind of okay, but we're getting to the point where it wasn't really okay anymore. We're getting close to these 1 MIP machines. We had a VAX 780, the big honkin' VAX. And it had 4 megabytes of memory, so, that was way more than we had on the PDP-11. So at any rate, we were trying to understand, was the problem that it was just because of bad block layouts, or was it because the block size of the file system was sector size, so 512 bytes. So we decided to increase the block size from 512 to 1K. And by doing that, we could see, how much does bigger blocks help? Well, the answer is it doubled the performance, because even though the blocks were still just as badly laid out, there were only half as many to read a file once they were twice as big. And so we forgot the idea, okay, bigger blocks is good, but of course disks in those days were small and they were delivered from the manufacturer full, and so everyone was constantly trying to cram more stuff on. And so we really couldn't just keep making the block size bigger because we'd have too much wasted space. So the idea then was going for bigger blocks is good, but we really still need to be able to store small files in smaller bits than a full-size block. And of course, the layout does matter. And so we need to do something besides a linked list of the free blocks. So we used a very exciting data structure for the time. It's called a bitmap. All right, so that was the birth of the fast file system, 1982. Actually, 1982 was when I was first willing to put my home directory onto it, and I convinced some other people in my office too, with great suspicion on their part. I never did actually kernel a file system. I did, however, screw up on the dump program, and so I forgot that when you were dumping things, you would dump it block by block by block. But I forgot that the block size we used on the tape was 1K, and that the blocks in the file system could be as small as 512, and so you need to round up. Instead, I was rounding down. So anything that was only a 512-byte file got nothing on the tape.
And turns out most of the directories actually fit in 512, so we actually recovered, except we had almost no directories. So we didn't know what the names of any of those things were. Yeah, sigh. Anyway, that's another story I won't give here. So what did we do with the new file system? The idea, hybrid block size, so you could have big size blocks and smaller fragments, up to a ratio of 8:1. Then the big files would use big blocks, and the small files could be as little as a single fragment. When we first deployed it, it was with a default block size of 4 kilobytes, and that gave you 512-byte fragments, so the smallest files still fit into a single sector. So we didn't really waste any space on those things, i.e. it gave you just as good density as you were getting before with the old file, the really old, before we even changed it to 1K. And as was mentioned, this is still in use today on things like FreeBSD and Sal6, and of course in many of those systems, including FreeBSD, ZFS is now supplanting a lot of the usage, but ZFS requires a lot of resources to operate well, and so I'm not really that worried that it's going to go out of existence, because there's a huge number of still 32-bit machines which can't really run ZFS very well, and embedded systems where they just don't happen to have 16 gigabytes of memory available. For what it's good for, it's still good for that. And even for things like Netflix, they're not running huge file systems, but they need maximum throughput. And we don't do the things like checksumming and other stuff that kind of slows down ZFS a bit. I mean, it's indispensable for the reliability that ZFS has, but it also comes at a cost. I mean, when you got tons of cores, so you can just say, those 8 cores are just going to do checksum all the time. Great. But on the embedded systems, again, you don't tend to have those kind of resources. All right. So back in 1982, when you operated disks, you actually had to know what the exact geometry of the disk was. So if you wanted to read a block, you didn't just say, go get me block so-and-so like you would do today. You had to say, all right, well, let's see, that's going to be on track 27. And so you initiated a seek, which moved the head from wherever it was to track 27. And then you would get an interrupt back from the disk controller saying, okay, I'm on track 27 now, what do you want done here? Or cylinder 27, sorry. And then you'd have to say, all right, well, there's these heads, and so I need you to switch down to head 7, and there was a rotational register that told you where it was, and so switch to head 7, skip over the next 3 sectors, and then read 2 sectors. And the disks, you talk about how you can have 2 disks connected to the controller. Well, in those days, you could have multiple disks connected to a controller, and you could have overlapping seeks going on, but you couldn't have overlapping I/O because there was only the ability to do I/O from one disk at a time. So you could initiate seeks on a bunch of them, and then when the completions came in from that, you'd sort of look where they both were and say, okay, this one is closer to the data it needs, so I'm going to do the transfer on this one, and then when that transfer completes, then this one will be getting closer to where it needs to be. So there was all this stuff where you needed to know the exact geometry of the disk and have all this stuff built in. And so there were tables in the fast file system so that, for example, if you wanted to allocate a block and the next one wasn't available contiguously, you could say, but one 3 platters down is available, so we'll just take that one instead. So they had these so-called rotational layout tables. So we were actually able to get the effect of nearly contiguous layout even when we didn't have exactly contiguous blocks. Well, by 1986, the disk manufacturers were getting away from that level of granularity, and in fact, by that time you just say, look, I want block 524, and it would just figure out where that was. And it still theoretically gave you the number of cylinders and tracks and all that, but it was just a fictitious number. It had nothing to do with the physical geometry of the disk. And so trying to do any kind of layout based on rotational stuff was just, couldn't do it. And so we just said, great, we'll just get rid of that code, and instead just start trying to do things with contiguous layouts or alternating block layouts, depending on what made sense. I will say that the initial fast file system in 1982 had 1,200 lines of code. In 1986, we were able to drop 300 of those lines of code in order to get rid of all this rotational stuff. So, in fact, we actually made it slightly smaller in 86. And you may be wondering why we had to go from 400 lines of code to 1,200 lines of code. It turns out that most of that additional code was actually implementing new system calls. Some things that, people sort of take for granted today, but make dir and rem dir, you used to do that by making nodes and creating links for dot and dot dot and so on. And we came up with this concept of why don't we just make this a system call? And we had this steering committee that was supposed to be helping us make these decisions, and one of the people on the steering committee was Dennis Ritchie, and so I got up to do my presentation about all this new technology that we were going to add to the file system. We were going to add these library routines, open dir, read dir, close dir, and unfortunately I was idiotic enough to put in seek dir and tell dir, which I regret to this day. But the idea was, since the programs used to just open the directory and read and interpret the data that came off them, and since we were going to change the format of directories, I didn't want to have to teach every program about which kind of file system it was on. So that was the impetus for that. One of the reactions to one of the steering committee members was, "Do you realize how many programs you're going to have to change?" And it's like, yeah, it turns out there's 16 of them. Be still my heart. That's like, a third of all the programs in Unix. Anyway, you could do stuff in those days you couldn't do today. Anyway, so there was make dir and rem dir, but then there was also rename. And so Dennis Ritchie sort of asked me, he said, well, I understand renaming a file. Are you going to allow the renaming of directories? And I said, well, yeah, of course. It's got to be a general interface. He goes, but when you rename a directory, just within the directory that it's already in, you're not going to move it to some other place. And I said, oh, well, of course, you can move it any place else. You'll just have to change dot dot. Now, how hard can it be? Dennis kind of looked at me and said, yeah, I think you're going to find that's challenging. Yeah, well, it turns out it was challenging. It was very challenging. In fact, it was 400 of those 1,200 lines of code. And not only was it 400 of those 1,200 lines of code, but it had some really kind of serious bugs in it. And I fixed the last of those bugs, actually, the 12th one, just a few years ago, and I'm sure there's none left. No chance. Okay, well, there's maybe a deadlock or so in there, but...
with exactly that.
Yeah, okay.
Just one little bit.
All right, so moving right along here, since I'm up to 87 and I'm third of the way through. Okay, speed it up, McKissick. All right, file system stacking. So we had this notion that it'd be kind of cool if we could just sort of, instead of having all the functionality in one place, we could have these different file system modules, and then you could just stack them up to get what you wanted. And so here you could have something like a fast file system, and you could just locally access it if you wanted. But you could also just push an NFS server on top of that, and then locally, of course, you could just export that through a mount point. But then if you were going to go to some other system where you didn't have a uniform password and group file, then you needed to do remapping, basically, of the UIDs and GIDs, and so we could just slap that on top of the NFS server and export that through a different mount point. And there's no point in having this built into NFS because locally you don't need it. Why pay all the extra costs? You just use it if you need it over here. And similarly, we're not going to build NFS into this file system. That's a completely different thing. And again, so you just have this module. So what ends up happening is you have this notion that a request comes in and it goes through a layer. The layer can look at it and resolve it, or it can look at it and say, oh, well, I want to make some changes and then pass it through, or it can just pass it through. And so the default in one of these layers is just pass it through. So in this case, the only things this picks off is stuff that has a credential associated with it, where it will replace the credential with one with the mapping done. Then we get down to the NFS server, and it's going to be able to resolve a good deal more things, but if we actually need data, then it's going to fall through to the local file system. And if it gets all the way to the bottom of the stack, we have the operation not supported file system at the very bottom. So for example, you might add two more operations, let's say start and end transaction. And some file systems may support transactions, others may not. And so what will happen is that, a start transaction, it says, well, pass that through, pass that through, pass that through. Oops, we don't support that. But, you got down to something like ZFS. ZFS it's fine with transactions. It'll do that for you. And so then the answer would come back up. So it was kind of an interesting idea. We did some sort of amusing things, the local loopback file system, which is still used today, the union file system, which is kind of still used today, and of course NFS, which you can't get away from, much as you might like to. So the idea worked well. It started out as kind of an academic thing, but the idea has stuck and is still used today. All right, well, by 1988, it turns out that disk technology had started to get bigger, and so we decided to raise the default block size to 8K blocks and 1K fragments. Didn't mean you couldn't still use the other one, but the default, if you didn't say anything else, was to do this. It now means that the small files use a minimum of 2 disk sectors, but of course it nearly doubles the throughput at the cost of only about 1.5% wasted space based on the typical distribution of file sizes. Okay, so we get to 1990 and came up with this idea called dynamic block reallocation. It turns out that it became, well, I'm not going to give the whole technology, but the older disk controllers, you couldn't really lay things out contiguously because you'd request a block and you wouldn't get the interrupt until it was completely done, and then you'd say, all right, I want the next block, where you just missed it, so you'd have to take a whole rotation before you'd get the next block. We didn't have track caches at that time, which of course resolves that problem. So it was actually more efficient to lay out files as every other block. But once we started getting track caches and tag queuing, things like that, it made sense to actually lay out files contiguously, and it has been pretty much ever since then. So, great, we want to lay files out contiguously. Well now, what do you do when you get the first write request? Someone opens a file, so it's 0 length, and now they write a block. Okay, well that's pretty easy. You can put it, someplace, but where do you want to put it? Is it going to be one block and then they're going to close the file and we're done? If that's the case, then we should find someplace where there's exactly one block on the disk and put it there. But if it's going to end up being bigger, then we want to put it someplace where we're going to be able to continue laying blocks out contiguously. Well, of course, we don't know until later what it's going to be. And so you'd say, well, just, you've got all that big chunk of contiguous space, put it there. Well, then if you end up writing lots of small files, your big chunk of contiguous space is gone, and you don't have big contiguous space when you need it. So how to deal with this dilemma? Well, what we actually end up doing is we say, all right, well, we're going to assume in all cases it's going to be a small file. So we put the small file exactly where it will fit. And then what happens is when you write the next block, we go, you actually need a place where we have 2 blocks together. So we go find some place where we have 2 blocks together, and it's, we move it from here over to there. Except we don't really have to move it because it's just sitting around in the buffer cache anyway. So all we really do is go into the buffer cache and say, well, when you finally get around to writing it, I told you there, but actually now I want you to write it over here. And then when you add the 3rd block, it's like, oh, well, actually we want it here, oh, we want it there, So it sort of moves around, at least where it's going to be written when it's finally written, and eventually we discover, oh, this is actually one of them big files. And so now we move you over to the big contiguous area, and we lay you out as a big contiguous file. So this seems like a pretty simple idea. It's about maybe 50 lines of code, and it turns out to be wildly successful in the sense that some folks at Harvard decided to study how well it did. Well, of course, any fool can do well on layout with a brand new file system because the whole thing is contiguous to start with. What's really interesting is what does it look like after you've been using it for 2 or 3 years? Well, how do you actually study that? Well, what they did was they took one of their central file servers and they took a trace of basically every file allocation and removal over 3 years. And then they just had this set of essentially allocations and removals that they could run against a file system. And it took about 3 days to run 3 years worth of this stuff. And so they would create a new file system and run 3 years worth of changes and then see how well it was doing. And what they found was you sort of get this exponential fall off and it sort of eventually levels out. And most file systems get where they're at about 65 to 70% of their throughput in terms of how they're able to lay things out. And what they found with dynamic block reallocation was it plateaus at about 85%. 85 to 90%. So it turns out it's a great idea, and so, when you get results that are that good, of course, you write papers and try and get people to do it. To this day, I don't know of any other file system that does dynamic block reallocation, and I do not quite understand why.
Not invented here.
Sorry?
Not invented here.
Yes, the answer is, it was explained to me, it's the not invented here syndrome. Okay, so the 1996 rolls around, and at this point, we pretty much have solved how to make large file behavior work well, which is to say we can lay them out contiguously, we can read and write them really quickly, for a long time it was the large file behavior that mattered, because the little files, the time it takes to read a small file is kind of immaterial. It's really more about just making sure you keep it cached if it's being used a lot. But then this new thing came into existence, which some of you may have heard of. It was called the World Wide Web. Well, the World Wide Web was all about small files, and in particular, they like to do a whole bunch of this so-called dynamic content, which means that you have some program that creates a little tiny file which you then send out and then delete the file. And so the behavior that you experience with a World Wide Web server running on a file system is, how good is your small file create-delete behavior? Well, you may recall we did that with 2 synchronous writes to create and 2 synchronous writes to delete, and you can do about 200 synchronous writes per second on a typical spinning disk, and that means you could do about 100 file creates and deletes per second, which on a active World Wide Web server is not really considered very good. So we needed to somehow improve the small file performance. And this was mostly done with logging or journaling, but we had to be different. And so this guy at CMU had come up with this thing called soft updates that I heard about at the Usenix FAST conference, this File System and Storage Technology conference. And it looked really cool. And so I got his implementation, which had been done in Fortran. But I converted it to a lower level language called C and dropped it into the system. And it has the same effect that you would get with logging or journaling. In fact, it does slightly better in terms of performance. And so that it essentially lets you get rid of the synchronous writes, but still keep the file system consistent. I'm not going to really have the time to go through all the different ways of keeping the file system consistent, but we started with synchronous writes. We moved on to the idea of using non-volatile RAM, which would be wonderful, except machines don't have non-volatile RAM for the most part, so we had a file system that was ready to go and no one to take it out on a date. So atomic updates, journaling or logging. Journaling means you're just tracking the metadata. Logging means you're tracking data and metadata. And that's pretty much the technique that's used by most of the commercial file systems today, certainly things like ext3. It's what NetBSD uses in theirs. And it's what Solaris used for their UFS, and in fact they use logging on ZFS. Moving forward in time, though, you come up with this notion of the copy on write file systems. LFS was actually the first of those. That came out in 4.4 BSD in the early 90s. It was an interesting prototype, but it didn't do a very good job of tracking which blocks were free. It had to do garbage collection for that, and that turns out to not be all that great an idea for a file system because you get these pauses that don't really refresh. At any rate, moving on, the ideas of LFS were picked up both by Sun and ZFS and Network Appliance in Waffle. The main advances that both of those systems made was to get rid of the garbage collection and actually have more complex techniques for tracking the free blocks. They do it in vastly different ways, but they don't have to garbage collect. Okay, and then finally there was the soft updates, which is the technique that we used in the file system for the FreeBSD and file system. Okay, well, the other sort of thing that came about once these log structured file systems or non-overwriting file systems came out was for them, it's very, very easy to take a snapshot because they aren't ever changing anything. You say, all right, I want to, checkpoint the file system right here, and then you just keep that checkpoint lying around. That's your snapshot. So other than having to track which blocks are being freed, that's about the only hard thing you have to do. What snapshots then were, they just became a feature that file systems are expected to have. And so, of course, we had to keep up with the Joneses. We needed snapshots too. Well, it's a little harder to do it with an overwriting file system because you got to do it as a copy on write, which means every time there's a write to the file system, you have to check and see whether it's a block you care about, and if it's one you care about and haven't copied yet, you have to make a copy of it, and blah, blah, blah. So it can be done, but there's a fairly significant overhead per snapshot, and so administratively we limit you to 20 of them because if you have more than that, the performance becomes intolerably slow. They're there, they work, but if you really want to use snapshots, I recommend you use ZFS, at least in FreeBSD, or Waffle, obviously, if you're using that system. Okay, so 2001 comes rolling around, and guess what? Disks have gotten bigger, and so it's time to raise the block size again. So we go to 16K blocks with 2K fragments. We waste more space as the last time we did it, so we're now wasting about 3% of the disk space. But the disks have been, from about the mid-90s on, have started getting significantly faster really pretty quickly. And so we're getting away from this notion that, every block is sacred and we have to make optimal use of it. People really don't care if you waste a little bit of space. And the non-overwriting file systems have kind of led the way on this because with UFS, you can run right up to about usually 95% of the disk space being utilized. And we don't even tell you that we're holding the other 5% because if you knew it was there, you'd whine about it. So when you do DF, it tells you what the capacity is, not what actually is there. The capacity being scaled so that when we don't want to give away any more blocks, it says it's full. Of course, we do give away blocks to the super user, so you can in fact reach capacities that exceed 100%. When this happens. I had one user wander into my office and say, you know something about this file system, right? I'm like, yes. They're like, so when I do DF and it tells me that it's at 103% of capacity, how does it do that? It was, I don't know, I was in a humorous mood that day or something. So I sort of looked at them semi-seriously and I said, well, of course, we don't let the users have more than 100% of the capacity, but if the super user needs it, we figure it's really important enough that we should go the extra mile. So what we do is we start storing the data on the parity bits. They didn't laugh. They looked at me with this perplexed look on their face and said, "Isn't that kind of unsafe?" Okay. Anyway, you can crank the min-free, which is the thing that controls what that is, down to 0 if you want to. And FFS will just keep plowing ahead and let everybody run the disk completely out of space. And you lose throughput by about a factor of 2 for the files created during that period of extreme shortage because the layouts obviously can't be very good. There's only 3 blocks on the disk. What's the best layout for that? It can be made to work down to at least 95% with ease. When you get to things like the non-overwriting file systems, the general recommendation is not to fill them more than half full. And absolutely don't go past 75%, because once you get past 75%, things start to really get pretty bogged down. And when you get to 90%, you're just done. Forget it. It won't deadlock, but it'll feel like it's deadlocked. So once we get to that level, the fact that we go from wasting 1.4% of the space to 2.9%, it's just like so out in the noise. So that's why we raised the block size. Okay. Moving along, we had soft updates, as you saw from 6 years earlier, and with soft updates, the file system is always consistent. It's behind the in-core state, but it is consistent, which means that if you crash, you can just immediately reboot. You don't have to run FSCK, you don't have to run a journal rollback, you just reboot. And you can crash again and reboot again and crash and reboot to your heart's content, to the extent you can be content with crashing and rebooting all the time. But you don't have to do anything, you just keep running. But the problem is that the one thing, the sort of one fly in the ointment is that you can lose blocks. That is, the bitmap will say a block is in use, even though it really isn't. And so you have more and more of this kind of lost space, and at some point you need to reclaim that space, because otherwise your disk will appear to be full when in fact it's really only 3/4 full. Okay, so you can do that with a regular old FSCK, but with a large file system that can be a long time, and of course the file system has to be offline during that period of time, and most people don't want to have their file system offline for, say an hour in the middle of the day. So we said, well, what we're trying to do here is just find this stuff that's lost, and we can take as long as we want to do that, because it's obviously not going to be used until we find it and give it back. And so this is an ideal candidate for some kind of a background garbage collector. Well, I'd already written FSCK, and there was no way I was going to do that again. And I looked up how to do, garbage collection on an active system, and that looked hard. So I said, what we'll do is, we'll take FSCK, which thinks it's on an offline static file system. We'll just take a snapshot of the file system, and we'll run FSCK on the snapshot, because it's static, just like FSCK expects. It's going to find a bunch of stuff, but we know that even if it's 3 hours later, when we finally finish doing that, it's still going to be lost. And so we just take whatever it finds and then just tell the file system, okay, this stuff's actually here. So all we have to do is run FSCK all the way to the end, and the very last thing that FSCK does is update the bitmaps to reflect reality. It can't do that because its copy of the bitmap doesn't look anything like what's actually out there 3 hours later, but we can add a system call which allows FSCK to say, okay, this block is actually free. And this, and this inode is actually free. And so under the regular locking while the system's running, those can be put back in as being available, and voila, suddenly you got your free space back. So background FSCK, you just snapshot it, run it, etc., and it finds all that stuff, and away you go. Okay, so that solved that problem. I talked about that already. So 2003 rolls around, and way back when I did the original file system, the original version 7 file system actually used 24-bit block pointers. And the idea was, again, they were trying to make the inodes as small as possible, so by having only 3-byte block pointers instead of 4, they could make it more compact. Well, at the time that I was writing the new file system, I hated all this thing of every time you picked up blocks, you had to convert from 3 to 4 bytes and back when you wanted to store them. I said it'd be much more efficient, just use full longs. And Bill was like, oh, you don't really need those extra bits. But I agree with you. It'll save some time, and we can waste the space. We can go from 64-byte inodes to 128-byte inodes. So we did that. And Bill explained to me back at the time that, in fact, 32 was more than we could ever possibly need. And he had this argument about, the density of you can have stuff on disks, and a disk platter can't be more than 3 feet in diameter, and so therefore the maximum amount of stuff you can ever put on a disk is blah. And I don't know, physics changed, or maybe there was a slip digit or something, but by 2000 or so, we were beginning to see disk arrays, at least, that were beginning to approach having 4 billion blocks on them, and that was kind of how many things we can do with our 32-bit block pointers, and it was looking like that wasn't really going to slow down, and so we better start getting ready for it. So we, first of all, changed the maximum file size to be a 64-bit size, but we also realized that we were going to need to have 64-bit block pointers. And so, of course, we wanted to keep compatibility with the old thing, so we came up with this thing called FFS2, and the idea of FFS2 was that it would be one that would have 256-byte inodes with 64-bit block pointers in it. But we also would continue to support the old UFS1 format. In fact, you can still create UFS1 file systems, and those embedded people, many of them still use it because they don't have disks that are that big, and they don't have enough memory, and the smaller everything is, the happier they are. So, they don't even run soft updates because that's an extra chunk of code they don't want. And they're perfectly happy to run FSCK on their disk because it runs in about 11 seconds, so who cares? Anyway, while we were at it, while we were revving the file system, we considered adding some other things. So we, in fact, we added a fourth time so that we could have the create time of the file. But we didn't go from 32-bit to 64-bit inode numbers, which I kind of regret at this point. But it meant that we could reuse all the same directory code, anything having to do with naming, etc. And so, in fact, if you look at UFS 1 and 2, they aren't two completely different code bases. It's just a single code base. And there's about 10% of the files where we actually have a duplicate version, one for UFS 1, the other for UFS 2. The rest of the places, there's just a macro where you need to deal with a block number. It just says block number, block, open paren, the thing you're looking at, and it just extracts a 32 or 64-bit depending on which kind of file system you're running on. So what it meant was that we had something that was previously stable, and this one stabilized pretty quickly itself because we didn't have to change the really hard stuff. Many of you have probably heard me rail on about file system development. Assuming that you're interested in doing coding in operating systems, which already says you don't want to do anything with a difficult algorithm, because if you did, you would be out in user land where you belong. But if you're willing to tolerate the fact that the most complex data structure you're allowed to have is a linked list, then the operating system is for you. And the other thing, though, is what part of the operating system do you want to work on? And if you're one of these people that likes to just, try new stuff all the time, then I recommend you do something like the networking area because it tolerates mistakes pretty well and doesn't typically crash the system. People will actually tolerate you crashing the system. They'll go for a blue screen of death several times a day. Pacific Northwest Company proved that. But the one thing that they won't tolerate is curdling the file system. If it comes back and the file system is curdled and they have to go to their possibly non-existent backup tapes to get that back, you will get a very nasty reputation. So you need to make sure that you never curdle the file system. As long, they'll tolerate you having to do something to clean it up and get it back into a consistent state as long as it can be done automatically without an intervention of a human. But so you want to be really careful. That's the one place where you really don't want to mess up. And so when I did the original design for the file system, I came up with this notion that we would have the policies and the implementation. And the implementation is the thing that actually whacks the bits and the bit maps and updates the cylinder groups, et cetera, to say what's actually allocated and what's not. And I wrote that code in 1982, and it has not changed since. Even here, when we went to this new version, that part of the code didn't change, other than the macros that looked at what the size of the block pointers were, and that was totally automatic. It just happened. So all the changes of all this stuff I'm talking about is really just changes to the policy routines. You can change the policy routines any way you want. You can come up with the most idiotic policy imaginable. Everything should be stored on block 1. And that'll get passed down to the implementation and go, oh, I'm sorry, block 1's not available. Let's see, the closest one we have out here is 4,327,000, so I guess that'll just have to do. But it will never allow you to double allocate. So, that's good. There's been twice since 1982 where I've seen things where it's like, if I just changed the implementation, just this little tweak, it would work, better. And in both cases, I overcame the thing saying I really shouldn't do this, and I did it. And luckily, during the period that I was testing, it curdled a file system. I was like, what was I thinking? Put that back. Don't touch that code. And so if you're going to do a file system, keep that in mind. Okay. So let's see. Pretty much talked about that. Further in the 2000s, a lot of what came about was a desire to have sort of more granularity, more security-related stuff added. So part of the extension where we went to multi-terabyte support was adding this ability to have so-called extended attributes. So it's an extra place where you can store stuff about a file that's not the contents of a file. So if you want, the user wants to store a little image that's going to show up on the desktop to represent the file, that kind of stuff. But it also gave a place for the system to put things, and so in that area for extra stuff about the file, in 2003 we added extended attributes. And it's this extra data storage that then allows us to store other things about the file. And the sorts of things that we put there are things like access control lists. So this gives you sort of finer grain control over who can access the file. So instead of just being owner, group, and other, as in traditional Unix, it lets you specify a specific list of users or a specific list of groups, and for each of them, the read, write, execute permission, but also admin privilege, which is, are they allowed to change aspects of the file, like, say, the access control list or the mode or whatever. Okay, so the implementation of access control list had originally started as this sort of external data structure that was just sitting on the side with fixed size things, so you could have a sort of a fixed upper bound on how many users or groups or whatever. So that was one limitation. Another one was when you do an fsync, you want all of the state about the file to be synced, and what would happen with that was you had to sync both the file plus that other auxiliary file, and so you could end up getting this synced saying that it had new attributes, but the attributes weren't synced, so it was very hard to do it all in one fell swoop. Once we moved it into the extended attribute area, that's part of the inode itself. So updating the inode, getting the inode written out to disk, by definition atomically updates both the file contents and the access contents, or the attribute contents. So moving the stuff in there was extremely beneficial to do that. Okay, so then along about 2005, we get mandatory access control. People sort of don't quite understand the difference between discretionary access control and mandatory access control. Discretionary means that each individual user gets to make decisions about how their particular resources are going to be accessed. Mandatory access control is a system-wide, so the system administrator makes decisions about how things are going to be done, and the users don't get any say in it. They just have to go along with whatever the administrator has set. This was, of course, originally done for the U.S. military because they want to be able to essentially lock down machines and have very detailed control over all aspects of everything. So commercial mandatory access controls tend to be different than what the military wants. The military wants very good control over who, for example, is allowed to look at a piece of data along with the integrity of the data. Commercially, it tends to be just the integrity they care about, not so much who looks at it. So you think about banks, for example. They absolutely don't want you to be able to walk up to an ATM and just make money appear in your account if you haven't got a legitimate reason to do that. But if someone else sees what the balance of your account is, it's like, well, it's not great, but they're not going to go to a great deal of effort to make sure it doesn't happen. So the point is then you have different sorts of access controls that you may want to impose on a system. So the framework that we put in place really just went through and looked at every place where anything was looked at or either accessed or modified, and puts a little hook in there. And there's literally hundreds of those points in the operating system. And the hard part is getting the framework in place. Thereafter, you then can create different access controls. So there'd be one set of access controls that uses those control points for what the military wants, a completely different set of access controls that you would put in place, say, for a bank, which might be completely different yet than what someone that's providing a login service at an ISP would provide. So the thing, as I say, the file system doesn't codify how these things get used or enforced. The file system itself just stores a label. So if you come and someone says, I want this label associated with this file, it puts it there. It doesn't interpret it in any way. It just stores it there. It provides it when the access controls decide they want to look at it to make some kind of a decision. And then, will allow that file to be used or read or whatever it is that's trying to be done. All right. Also, in the early OOs, we were going over one of the biggest humps that FreeBSD had to face up to that point, and it has, in fact, it's the biggest one it's ever had to face, and that is moving from a uniprocessor-based system to a multiprocessor-based system. The open source projects tend to be good at dealing with a lot of small things, but it's really tough to do something that's big, that requires the coordination of a large number of people. And we did it. It took longer than it should have, and there was more contention than there should have been. And in fact, Some of that contention is what caused one developer to be ejected, and he started the Dragonfly project because he didn't agree with the way we were doing SMP. But in some sense, you at some point have to make a decision about how you're going to do it, and then everybody just has to agree to do it. You can't be trying to do it 3 different ways. So it was an unfortunate outcome, but that's what happened. Anyway, symmetric multiprocessing was done in different parts of the operating system at different times. We started where there was a giant lock over everything, and then the giant lock was removed from subsystems sort of one at a time. What happened was, in this case, first it had to be removed from the VFS interface, then it had to be removed from the individual file systems, finally it had to be removed from the disk subsystem at the bottom. And so in 2006 is when it came through the file system layer, so that's where the fast file system got done. Actually, I guess the disk subsystem sort of got done before the file system, although it turns out not really. The disk subsystem didn't really become truly SMP until about 3 or 4 years ago. At any rate, that did happen, and it is fully SMP now. Okay, well, the next little bit of technology is, remember we did soft updates like in the mid-90s, and then we added the background FSCK, and that dealt with the loss of information, loss of blocks, putting them back. But even background FSCK didn't require you to have the system offline, but it still required that you give up like half of all of your I/O bandwidth for 2 or 3 hours. And you can do that whenever it's convenient, like say the middle of the night, but for some systems, they just don't happen to have 2 or 3 hours any time of the day or night that they're willing to give up to do background FSCK. And so it was like, can't we get rid of this background FSCK somehow? And, well, if you stop to think about it, it was at a dev summit in 2008 at BSDCon. This guy named Jeff Robertson was there, and he and I got into this discussion of how could we get rid of background FSCK, and he worked for Isilon at the time, so you can see why they might have cared. And he said, well, the only thing that soft updates isn't really dealing with is that it gets everything actually correct until it gets to the point where it's putting the blocks back in the bitmaps and it's not really tracking those going to the disk. And the way soft updates works, that's not really, you could do it, but it would be very contorted. He said, but supposing we journal just the updates of the bitmaps. That's the only thing we're going to journal. And then we can just do a journal rollback and after a crash, and all it's going to do is put the things that should have been in there. So it won't take very long. How hard can it be? Anytime someone asks that question, run. Do not walk in the opposite direction. But I've been around the block long enough, and he was only in his 20s, so old age and treachery will overcome youth and enthusiasm every time. And so I said, that's a great idea. Why don't we do that together as a project? And so I had sketched out kind of the way it needed to be done and sent him the ideas and the data structures. And being the kind of person that could type for 16 hours at a time, he just went, and he was in the far enough away time zone that I would send something and go to bed. And I'd wake up the next morning and boom, in my mailbox would be like 1,000 lines of code. And I could barely keep up with this code and send him, some mail and say, well, what about this and what about that? Maybe you should do it like this or that, and go to bed. And when I'd wake up the next day, it'd be like, well, let's see, you had 3 things. That one was idiotic, so I'm not even going to comment on it. That one looked like it could be okay, but don't you think it would be better to do it this way? No, that other one, that was a good idea, so I've done that here. Another 1,000 lines of code. So anyway, it only takes 12,000 lines of code to implement journaled soft updates. But, once you've got it and it works, it's great. So I highly recommend find someone that's like in their 20s or early 30s to do the coding, and then you can just sit there and pontificate, and it's really easy to get really complex things done. Okay. All right, so the journal only needs about 16 megabytes of memory. It's independent of the file system size because it's really just how many transactions you're doing, not how big the file system is. And I don't really have time left to go through how it works, so go read the book. 2011 comes around, we raised the block size yet again, so we're now at 32K and 4K, and you'll notice we're not wasting space anymore because the disk technology has changed where the sector size is 4K, so that we're now back to the case where the fragment size is the sector size, so, yeah, whoopee, we just solved that problem. Okay, and again, it doubled the throughput like it always does. So the most recent thing that I've worked on is something which came out of another one of these FAST papers. Someone realized that if you, instead of laying the metadata out all over the disk, all the indirect blocks are basically spread out all over the disk. They sort of get allocated near where the blocks they're associated with are. If you put all of that metadata together at the beginning of a cylinder group that the inode resides in, first of all, I mean, what the point they were trying to make was it made FSCK run much faster because all the metadata is in one place. You didn't have to run all over the disk to collect the indirect blocks to do the check. So it literally doubles the speed of FSCK. But it also turns out to just speed up the operation of the file system in general. And the reason is when you're looking at a big file, especially if you're looking at it with random access I/O, all of its indirect block pointers are sitting together contiguously in one place on the disk. So it goes to that one place on the disk. The track gets read into the track cache, and thereafter, anytime you need any of the metadata, it's just a hit on the track cache. And so even though you start up doing random access I/O, it's instantly fast. So it was a great idea. They did it in Linux, and they had to take about 3,000 lines of code and change the format of the file system. So they, to this day, haven't managed to get it into Linux yet. But it was only a 100-line change of policy routine for me. So it's been in FreeBSD for the last 2 years, and it works great. Okay, that's it. Questions? Yes.
So you mentioned how hard it is to implement rename. In hindsight, would that be easier if directly being stored dot explicitly?
So he interrupted, so I have to repeat the question.
Oh, yeah.
So just the very last part.
Yeah, would it have been easier to not store dot in directory explicitly?
Would it have been easier to not store dot and dot in the directory? Yes, that is certainly true. The problem is that you need dot all the time. And so it's one of those things of, if we simplified it, wouldn't it be easier to implement? It'd be, yes, it certainly would be easier to implement, but it wouldn't work because people need that particular bit of information.
Yeah, but let's say if only, so dot itself is not really that useful, but dot you would only store like the inode numbers inside of the directory inode itself. So that the inode just points over to the parent instead of storing it in the directory. Because I remember that like creating a directory, renaming a directory requires like multiple soft updates.
Yeah, so the question is, wouldn't it be better to implement it by putting, instead of having the name in the directory with the number there, keep that information in the inode itself? In that case, I would agree, yes, it would be. You still would have to make it appear that dot was there, so you would synthetically have to create it on the fly. That you could do, and that would probably be, as an implementation thing, probably a better way to do it. It would certainly ease the task of renaming. On the other hand, rename is one of those things that's really, really slow, and people are like, oh, this is so slow. I could, optimize that, and it's like, yeah, except that how many of those are you doing per second? It's very rare that you're doing very many, so getting it right is really the important thing. And so the fact that you have to do a few extra IOs is not great, but it's not the end of the world. It's not like it was in the mainline code. Yes?
That same idea that it's not important yesterday, but Taylor Campbell told me that actually when you're doing transactions like in the database, you often have that. You create a temporary file, put data into it, and then move the temporary file in place. However, that's usually inside one directory. So I guess you will say more about that in the next talk. So continue right.
All right. I'm not going to repeat the question because it's more of a comment, so. Yeah.
Is there any chance that we will get dump for journal soft updates back?
Is there any chance?
Live dump for journal soft updates broken, has been for years.
I'm still not sure what you want to get back snapshots?
No, yeah, snapshots for dump.
Right. Okay, so yeah, so the question was, are we going to get the consistent dump back with soft update, journaled soft updates? The problem the issue that's rising is that with journaled soft updates, we turned off snapshot capability. What we've really, the thing that's hard to do is have a snapshot consistent across a reboot. So we actually worked out what we need to do to fix the snapshots, and to sort of get the exact semantics correct, that's probably what we would do. But it turns out that people aren't really don't need long-term persistent snapshots. They mostly want to use them for things like FSCK and dump. So a short-term solution that it seems more likely we will do is say that you will lose all snapshots across crashes or inconsistent crashes. If you unmount the file system and remount it, you won't lose them. But if it comes back after a crash, you will lose them. Given that we don't let you have them at all now, for a while that would have been a problem, but now that we haven't let you have them at all, people will be so happy to get them back that they'll probably be willing to tolerate the fact that they lose them across crashes. So that's my current idea on how to solve that particular problem. Okay. Any more questions? Actually, I'm like way out of time here. So feel free to, I'm here for the rest of the day, so feel free to buttonhole me and ask. Thank you very much.
Thank you very much. Very interesting.
Well, it's the stories, right? Yeah. No one else can, anyone else can compete on the technology, but stories is part of it.
Could I trouble you to sign my book?
I'd be happy to do that.
Awesome.
I really wouldn't mind losing snapshots during reboots or crashes, because the first thing dump and fcheck do is unlink their snapshot.
Yep.
Oh, yeah.
Well, there you go.
Get it autographed. But I looked at the wiki and it said neither George nor Robert. And
I've been trying to track Robert Watson down for a while now.
he hasn't come to BSD
He
camp.
doesn't show up anymore. No, he wasn't there.
He was at BSD camp this year.
Was he?
Oh yeah.
All right, I guess.
There you go.
Thank you.
Cam, not Cam. BSD camp.
Cam?
Yes.
Oh,
Cambridge.
Yeah.
Well, of course, he lives there, so
It's easy for
he
him to get to.
organizes
Yes.
it. He can't not go to it.
His office is like just down the hall.
Yes.
One very brief question. Did Masao Uebayashi reach you yesterday?
Who?
Uebayashi, a Japanese NetBSD and OpenBSD developer who gave a talk. Probably he didn't, so I'll just ask his question.
Okay.
He's interested to know who was the original author of the user SBIN config or etc config program in before Bill Joy and Sam Leffler started maintaining it.
That would have been Robert Ells
Oh,
from the University of Melbourne.
Robert L. Okay.
He's the first one that started trying to figure out how to configure the kernel. I should confirm that. He may not have done the config program, but I have the whole SCCS history of everything, so I can go look and see.
Oh yeah,
who
the
checked it
check-in
in.
was done by Michael Joy just before 4.1c BSD.
Oh, yeah, right, that's when we first created. I
so
forgot, right, only the kernel was under SCCS before that, so,
Yeah.
yeah.
So Michael Joy is definitely
Joy.
not the author, I think.
No, I don't think so. So, my
Okay,
guess, but
Robert
I know that Robert Ells was very early on was involved in doing a lot of the auto config stuff. And so I just assumed that he was probably the one that did an early version of config.
Did he have wait?
He was KRE was his.
Oh, yeah. That's interesting because Masao already talked to to KRE,
Say what?
and Masao already talked to KRE,
Okay.
and KRE said, "Yeah, I maintained it early on, but I'm not the original author, and I don't know who started it."
Okay.
So
Well,
okay, we still don't know.
We
That's
still don't
interesting.
know. If he doesn't know, then I don't know.
Sure. Okay, interesting. So one of the very rare cases where it seems that information actually got lost, because if you say it was him and he doesn't know where it came from, then who might know? Nobody probably.
Yeah, if he doesn't, I mean, if it already existed, then it may well have been Bill who, you know, made some
Oh yeah,
incredibly
he
tiny
might have,
prototype. I mean, you should actually go look at what that first check-in was and see how complete it was at that point.
Yeah. That probably.
Yeah, but like I said, the problem was that a lot of stuff was not under SCCS. I mean, SCCS didn't really come into existence until 79 or 80, somewhere in that area. And initially we had only the kernel under it, and then a few user programs. And then actually it was when 4.2 came out that I ran around and actually said, look, for a long time we were just shipping random binaries. We didn't recompile things.
On a changé les...
Yeah.
celui de... Ah, mais je croyais que j'étais là, moi, dans le truc. T'es sûr que c'est l'autre? Oui, oui. C'est qui est là, alors? Parce que moi, j'étais sur la rouge, hein.
Moi, je veux que tu restes là.
Qui c'est qui c'est?
Ouais, je suis d'accord.
Qui c'est?
Oui, c'est vrai.
Parce que moi, j'étais là, hein, sur le premier schedule.
Non, puis je me suis assis, je me relève pas.
Eh, putain. Et quelqu'un qui peut valider que c'est bien là que je reste?
Moi, je valide.
Ouais, pareil.
Et qui c'est qui a le... Comme pas le papier?
T'es marqué là?
Je suis marqué là? Ah bah voilà, c'est bon. Merde, j'ai rebooté ma machine du coup.
Ah, quel le bug de la passe-phrase
En UEFI, ouais. Ouais, comme je peux pas faire d'X-Render parce que Broadwell, je suis obligé de tout envoyer là, c'est super pratique.
La résolution est un peu grande pour...
Ouais, bah 1920, c'est ce que balance ce que dit l'écran qui...
C'est ce qui s'est pas fait le projecteur, c'est ça?
C'est ce que c'est vers le projecteur, c'est lui qui annonce, hein.
Non, c'est parce qu'il y a de l'anti-aliasing, c'est moche, mais...
C'est pas grave, il faut que je prenne notre présentation. Ok. Je prends les fenêtres. Hi. Yeah, I have to repeat the questions.
It's very typical Swedish. It's like, do this. In other European countries, you say s'il vous plaît first.
I would have probably done the same. I mean, just do it.
No, you would have said s'il vous plaît. Repeat the question. Or Englishman would say please. The German
Yeah.
would say bitte, but the Swede is no.
Yeah. But I mean, I would have probably, if I were to run it, I would probably avoid the s'il vous plaît. Just because it's shorter.
You should make the Swede.
Things are pretty solid. A couple of years ago, I with the rec hook on the street. It
Salut.
Oh, yes. 20 seconds. I'll be in and out in a second.
Okay, go on, faster. This is the torque you're looking for. Okay, have a seat everyone. We're running late. Okay, let me introduce to you Baptiste Darroussin, part of the FreeBSD team, Ports team, and whatever team, author of PKGNG and Pudelia.
Okay, hello everyone, thanks for attending. So I'm Baptiste Daroussin, I'm a Unix system engineer working for Gandhi, mostly responsible for breaking the package system on a regular basis. And I'm also responsible for having written the new package system, the new package builder that is used on the cluster. It's used on a lot of places. And a lot of people ask me, okay, it's there for a while, but you never came to explain us exactly what it is, so that's what I'm coming here for. So, Poudrière is the name of the tool. And so first, what it is. So if you want to pronounce it properly, it's written on the top. And the name is kind of unfortunate, because it was like a code name. It was not supposed to be public, not used widely, but in the end it replaced the existing tools in a way simpler fashion and was way easier to do, so it went out and kept the name. And now I'm quite happy with it because everyone tries to pronounce it all the time, and it appears that in almost no country someone is able to manage to pronounce it properly. So you have the pronunciation now. So what is Poudrière? It is a package building system. It helps you so to build packages as fast as possible. It also provides you some interaction so that you can test your ports, do some quality insurance on them. It's also good for being able to generate repository. So if you need to have your own package repository that you host somewhere, Poudrière will do all the stuff for you. And it's also system tracing tools. It wasn't designed for that at the beginning, but it appears, and you'll understand why later, that it helps a lot to figure out a lot of issues on a system and make sure that your system is very stable. A bit of history around this. So the initial work started something like 5 years ago. Like all those kind of stories started in a bar around the beer, and was just starting working on the package manager, and I needed a tool to be able to generate packages to go with. And I looked at what we had back in the time in FreeBSD. So we got Tinderbox, we got the port build system, which is kind of fork of Tinderbox. It was used on the cluster. And I couldn't very easily set up both of them. I could set them up, but it required a lot of interaction, and I just wanted, okay, I got my tool, run, and done. It's set up, workable, and usable. So I started writing my own. The name Poudrière started at the second commit. The first was tinder.sh. And it was supposed to be kept for me to build those packages. But in the French community, a lot of people heard about it and said, yeah, it's nice because I always fail at installing Tinderbox, and your version seems to do the same thing. Can you please share with me, and then you start to share again, and it ended up in the post tree. And so 2 years later, we have a version which was stable enough and usable in the post tree. When I started to push that into the post tree, I decided, okay, so people will use it, so maybe I should make it a bit more safer than it used to be. So we started to try to contain a bit the build, making sure that you are not allowed to fetch something when you're not in the fetch phase, because when you build something, you want to get control on what's happening, and you don't want that the crazy build system provided by this crazy package tries to fetch something you never heard about, which you don't have checksums about, so you don't know if your maintainer have validated the content of this thing. And it appears that it was quite flexible, and I talked to the PCBSD guy, Chris Moore in particular, about their own package system. I was explaining them, okay, your own package system probably can be done almost entirely on top of package. You don't need to get your own stuff. And it appears that maybe I can also build your package for you. So I tried to make a front end on PBI as an example of the flexibility of Poudrière, and it appears it was something like 10 lines of code, nothing more. I wrote a parallel version for a package for Poudrière 2. So decided, okay, Poudrière is cool, very nice to install, but then you build the package one by one. Not all of them can build multi-threaded, so maybe I can parallel the build by making them, instead of multi-threading the build, I can build multiple of them at the same time, and then I can use maximum I can from your resources. And I wrote a very, very ugly HTML UI. So if you had something to do on the web, please never ask me to do that, because you will end up with something very crappy. We removed the PBI support because actually PCBSD started to move to package directly, so they didn't need to build any PBI, and I think they never used the PBI stuff I wrote. And we added support for sets in the 2.2 version. Poudriere was heavily based on ZFS because ZFS helped out a lot to be able to get clean rooms, prepare jail, duplicate that many times. But it appears that if you want to get faster, then you get to get everything into memory, and then you cannot clone the ZFS into a TMPFS. So being able to not rely on ZFS was important. Also, a lot of people didn't have a ZFS setup, or they don't want to deal with ZFS. We still have UFS, which is good for a lot of things as well. So being able to add more flexibility was important, and we did that for package 3.0. And the other important thing is, it was a bit earlier, that in 1.3 we attracted the interest of Brian Drury. He wasn't a committer yet, but this is very important because Brian ended up making all the maintenance of Poudriere, so that now I only have the fun to do in Poudriere, and he does all the maintenance, making sure that it's stable, it's not breaking, and that he makes release when it's okay. So it was very important, and he's now the most active guy on the Poudriere code. And so for the 3.0 version, he was scared by my web UI, so he wrote a new one, which is way better. This version was the first to be used in the cluster, FreeBSD cluster, so we replaced the port build system, which was very complicated to deal with. This new version, it was very interesting because port build was massively distributed, but takes way longer to build the 25,000 packages than Poudriere, which is not distributed, building locally, but parallelizing a lot of stuff and making sure that all your resources belongs to building packages and not to compute things around. And we ended up with very, very good numbers when building. Like we could build 24,000 packages in less than a day on one single box. We were even close to half a day, but since then, people in the wild open source community became crazy, and we got bigger, we got longer and longer build time on some crazy stuff like Chromium, like PyPy. There is two other one I don't remember. So all LibreOffice used to be the big one, but now it's just half an hour, while it's something like 8 hours, I think, for every single WebKit stuff. So yeah, LibreOffice now is tiny. I mean, it's VI. And then it's cool, you get new package system, you get a new building system, and you figure out that the way we build things in FreeBSD, the way we do stuff is very, very retarded. As we used to prefer to break your system and then trying to see if we could register properly and have a package instead of making sure we get something that works and then installing your package. So we're adding staging, and so we needed to add the staging support into the build tool. So 3.0.3 was added the support of staging, and there was an initial work of some crazy people about, I can use that to do some preliminary cross-building. Well, it's not cross-building exactly. It's more emulating the target and build the target packages the regular way via QEMU user emulation, and so you can build ARM, MIPS, PowerPC, Spark64 package with that. I find the idea crazy enough so that I can give them support, and I give them support, and it appears that it starts to work properly now. And in the latest version, I think the latest official version, we got a very good, better web UI. So Brian extended what he did on the web UI, which used to be one web UI for the build, into something which is more like a portal where you go through the different builds you have and you can check everything. So the design. Two things we got in mind when I got in mind when I started. It should be simple. I mean, you shouldn't have command line with thousands of arguments you never heard about. It should be simple to set up. If it can auto set up by itself, it would be better. It should be only relying on the base system, because otherwise you get the chicken egg problem. So you install the base system, you should be able to get Podria running and being able to build all the packages with no dependencies. It should also be extensible so that I can, if something is available like Git, like Portlint, like other external tools, then I can use them directly, but it should not be mandatory. One single and simple configuration file to do everything. So think a lot about how different parts of the Podria thing interact with each other, so that we get a very simple configuration file, and you can go through that piece of, you just go to that file, comment or uncomment what you want, and then start Podria, and it will do all the setup for you. You don't need to, I will set up a database here, I will also set up PHP here, Perl there, and try to make them together, and then, no. It should be resource efficient. When I looked at most of the alternatives on FreeBSD, what you figure out quickly is it spends a lot of time just computing things and not actually building packages. That's wrong. I mean, I run a package builder to build packages. I don't want that 2 or 3 of my cores are used just to compute UI, just to handle PHP, no. I just want all my resources for building packages. So we took a lot of care into how we code, how we organized things, the mechanism and the algorithm we use to do, to check the logs, to compute the dependencies, make a tree that we will build, so that it takes the fewer resources as possible. And so we want a very low overhead. And the last thing is we want everything to be safe and self-contained. So when you build, if you want to clean build, you need to build in a clean room, so that you don't get a header that is handling there, and then some of the crappy configuration script just figure out, you got this header, so probably now I will build this feature. No, I mean, you ask the package to be built with those features, to be only those features, so you make sure that your environment is clean and you don't get any pollution. You need to be safe, so you prevent everything to fetch when they are not supposed to fetch. So sorry, you cannot just get the latest master and build a package out of that, because you are never sure that what you get is what you're supposed to have. So you need to snapshot somewhere, something with a checksum, we ensure that you are building exactly the sources that were tested and validated for you. And we try to build as much as possible as a regular user. By default, don't remember it's by default, but actually it provides in Podria, we provide the feature in Podria for a while, and we try to build everything with the user, which is an equivalent of nobody, so that you get absolutely no access to anything. It's very important that pods can build that way, because if someone tries to just build on its own, then it can, if it doesn't trust the build system, which everyone should do, not trusting the remote build system, he can do that in a less restricted environment. So on the design, the idea was to get one single command, which is Podria itself, and then subcommands to do the stuff. So I don't define all I don't explain all the subcommands, but those are the main important. So basically, you have the notion of jails to manage let's say the base system. So you want to build for this or this version of the base system, you keep some jails around. You get the ports tree, so you can get different versions of the ports tree, one with your patches, one with this branch, one with this feature, or one that you remain on this revision because you don't want to update to something new. And then you get the bulk. The bulk is basically what is taking all the stuff and trying to build everything. So about the jails. So the jails, the point was also to be able to make them very quick. To create. So don't spend time on configuring, spend time on building again. So by default what it does is just grabs the latest sets from the releases, grab them, create a jail, mangle a bit some configuration files so everything is prepared to be running on Podria. and that's all. And if you want to update, then it runs FreeBSD update in it, so it's very fast. You get everything done very, in 2 minutes you get something ready to build packages. But we want flexibility as well. You want to build packages for head, you want to build packages for the latest table, you want to build packages for your own releases you do because you do an appliances. So we added support for all the snapshots that are available on our website, or if you use the release script from the source tree, then you can create your own snapshot and use that directly. And of course, some people don't follow the end of life, so we added support to be able to fetch from the old archive, so that if you're still on FreeBSD 8, you can still create a jail for that. We don't guarantee that it will work, but you don't want to stand into your path. But you also want more flexibility. I mean, you're building your own stuff, you're having your own patches on top of the source tree, then you want to be able to build your own directly. So you can put a jail to, okay, this is my own Git, this is my own, this is the official SVN, I want to build the branch, I don't know, Glabius has a project branch, then I want to use his branch and test packages on top of that. So you can just directly build the jails out of the source tree. It does all the magic for you. You have nothing to do except this is where I want my source to be fetched from. We fully support all the options of the build system you have already. So if you want to build something without NIS, because you don't need NIS anymore nowadays, and you want all your package to be built without NIS, then we can do that. We support multiple arches, so if you're an MD64, you're natively able to do both MD64 and 32 bits. But if you want to do ARM, then you can go through QEMU emulation. All the complicated part has been hidden from you. So all you have to do is to install the QEMU dash, I don't remember, the last one should be Sean Bruno, because he's the guy doing that and has a special patch. Just install the package, and then Poudriere will be able to use it. We can have kernel, so it sounds crazy. Why do we want a kernel inside a jail, or it's on CH root? This is related to something we're doing now at Gandhi that will happen I will talk about way later, but it's a new thing that is coming into Poudriere. And of course, we can update the source, you can update through FreeBSD update. So before building your packages, you can grab the latest security fixes. And it can be important because if you get security fixes on PNSSL, for example, and one of the header contains macros, then you probably want to get those properly, because if the issue was on those macros, then you want your package to be rebuilt with those. So how it works, with this simple command line, I can create an environment which is ready to build the FreeBSD 10.2. I didn't specify anything, so it will take the same architecture as the host. I give a name, which is -j. So the names are limited by the limit of jails themselves, because they are real jail in the background. So do not add any dot. I don't remember the limitation. I don't know if it's fixed, but it wasn't for a while. And -c to say create, and that's all. And with that, you can build FreeBSD 10.2 packages. You just want to update because there was a security issue, whatever, -u and done. You have nothing else. Keep it simple is very important. Now, we got the same thing to do with the ports tree. We need a ports tree to be able to build packages properly. So we fetch the ports through every single mechanism supported by FreeBSD. So we fetch through PortSnap, or we can fetch through Git, we can fetch through ASEAN. If someone wants to provide new mechanism to fetch the ports, then we will add it, as long as it is not too intrusive in the code and not adding too many lines. The thing is to keep the code simple itself as well. We have the notion of default ports tree, so that if you don't specify any name, it will be the default ports tree, and all your builds without a ports tree specified will use that one. And this is how you just create a ports tree. So in that case, I want to name my ports tree. I don't have to specify where it comes from, so in that case, it will use the latest head version, and it will be automatically using PortSnap by default. And you have created a ports tree, you have a jail, you have a ports tree, you can build packages. To update the ports tree, same thing as with the jails. And now we got those two things prepared. We need to create the packages or to test them or whatever. So we just associate jail with a list, with a port tree and a list of packages. We massively parallelize. So as I said, I discover, okay, you got a 24-core machine. Let's create 24 jails and build 24 packages on that. And if you look at the load average, you will see that we pretty much in line to the one per core, which is pretty good. And if you want to do finer grain things, you can just add in the configuration file. Please don't use more than 10 core, but try to parallelize all the build with 2 threads. Or so if you want to do some tuning, because for you it works better this way or this way. I know François on Dragonfly did some tuning when he tested. And you have all the liberty to be able to, all the freedom to be able to tune, fine-grain tune your build system. We can use a CC cache, so if you want to speed up your build, we can use CC cache. The CC cache will be shared among the different build you can do, so you don't waste what was cached in the previous build. You can do very, very fine-grained tuning on what option you want to apply to different ports. So to do that, you get a make.conf, and then you get, so the first make.conf is added to your jail, and then if you got a make.conf with a jail name, dash a set name, dash a port name, or it's documented on which order in the man page, so go in the man page, but basically we just append this to the same jail.conf. So to the same make.conf, so in the end you get very fine-grained options you can apply, like if you do in make.conf itself, then every single of your build would be without dots, for example. But for this particular set, because I want to push those packages over there, and I will activate, like, let's say, libreSSL for the by default as SSL provider. For this one, I will just activate SSL, then SSL by default for every single thing. Then you can go through those different make.conf and make them a very fine-grained tune. We got the nice web UI, so everything is static. As I said, we need only the base system, so we just generate some static file all the time, and then we got some magic JavaScript doing the stuff. So you just need to point a web browser, a web server to that directory, and then you get a dynamic website, but everything generated static. You don't need Perl, you don't need Python, you don't need PHP, you don't need stuff like this, just JavaScript. We got a nice command line interface. I really like tools with nice command line interface and not a cryptic one. So first it's simple as you have seen, but the other thing is if you start building it, you will see that you get all the information about, oh, this JS started to build this package, this JS started to build this package, it has finished this one, and you can see it took that amount of time. And we are on BSD, so we have a send signal thing which is called siginfo. So if you do -t, then you will see that in your log you get at the moment a list of all the builders you have running. So if you got 24 codes, you get 24 lines explaining, oh, I'm building PHP, I'm in the build phase. In the same time I'm building Python, I'm in the fetch phase. And this one is building this in doing creating the package, so in the package phase. And this build is going on for 3 hours, 8 hours, whatever. So you get a very nice interaction with the tool. We got hook support because we do bulk. Those bulk end up creating a repository, and you might want to do bulk so that you, for example, as soon as the full bulk is done and everything is okay, you can automatically synchronize things to your mirrors, or you can I don't know, go through some deduplication mechanism manually, or you want to add some different signatures or a schema than what we provide. I don't know, you can imagine whatever you want. So we added some hooks so that you can have your own interaction with the tool, and you can extend the tool as much as you want. We use that in the FreeBSD cluster to automatically propagate all the packages through the different mirrors. So we got generation of the repository which is included. We support by just an entry in the configuration file the fact that we will sign the packages for you. So default port 3 support I already said, and we got incremental support. It's very aggressive, so as soon as a dependency has an update, every single thing, the package has an update, every single thing depending on that package will automatically be destroyed and rebuilt. It's the only sane way to make sure that everything has been, because maintainers may forget to bump things there and there, or not figure out that, okay, I added threads to that library by default, but the ABI is a bit different and may break all the things over there. So we are very aggressive about that. But because we can build fast, it's not that important, except when you got getX that is updated. In that case, you get everything that rebuilds, but so we got restricted support, so we can build everything. When we build, we don't care about the fact that it's there is patents, there is stuff like that. We build everything. So we build with LAME, with MP3, video for all kind of video codecs. But when you want to get those packages out in the wild, you probably want to respect the law, whatever your country you are, and so you can just add, okay, please build, but remove everything which is restricted because I'm living in the US and I can't use that because of the patents. So in that case, until every single building goes through the different packages and say, oh, that one I will remove, that one I will remove, and you get something which is safe for the law of your countries. We have a feature which is, okay, it's cool, I can build everything, it's inside jail, it is isolated, but something fails. How can I figure out where it has failed? Because everything cleaned out by itself. So we can just create a tar out of the work directory and save the tar somewhere, so then you can study exactly the status of the work directory when it failed. And auto-detection of rebuild goes with incremental support, but not only. If you change an option, we will discover the option has changed, and then we say, okay, you don't have to by yourself know that this package needs to be rebuilt. We figure out, oh, the set of options you used when you build this and the set of options you use now are different, and this implies this package, just rebuild those. So if you just build something and then figure out, oh, I really don't care about native language support, then you just add native language support off into your make.conf, start rebuild, and only the thing that depend on that will be rebuilt. And the last thing I forgot to say is bulk. There is another version of bulk which is called testport, and it supports a -I option which is interactive, which means if you have something broken in the end, it will start up a shell for you and you end up in the jail exactly as I said, so you end up in the clean jail exactly at the moment where the build failed, so you can reproduce yourself and get interactivity with your port to make sure you figure out what the issue is. So how you bulk some packages. So imagine you just want to bulk a bunch of packages, you create a text file with a list of packages you want, and you run the first command. It will take the jail, the FreeBSD 10.2 jail that we created before. It will take the default port tree because I haven't specified port tree, and goes through the list, compute the dependency, add the dependency to the queue of the queue of package builds, and start the build for you. If you want to add some extra quality insurance because you are a developer, or you want to help to improve the quality of the packages, hash the -t. It has a lot of more testings. We'll test that you have actually packaged every single file you're supposed to package. No, the first one does it by default, sorry, but it will test that you didn't forget to add to your playlist some files. It will check that you don't have, it does a lot of testing. I won't say all of them, but I have a lot of testings. And if you want to build all the port tree because you're the FreeBSD project and you want to provide all the packages for everyone, just do -A. Or you are providing for your own users everything, like PCBSD, for example, they want to provide everything. They run their own version of FreeBSD with their own set of packages and their own set of options. So they probably also use a -A, and that's all. So keep it simple. You want a special set. I mean, I have this jail, this port tree, I have tuned everything in my make.conf, but I want an extra tuning because this machine will be exactly the same version of FreeBSD, but with an extra set of options. Then I have the -Z, test one, and I can have now test one make.conf, which also append to it, and then I can have a set for that. I don't need to create multiple JPEGs for that. Right, so when you get all of this, you start building stuff and you discover that you get a very, very, very nice stressing tool to stress the system. So what we figured out very quickly on FreeBSD is tons and tons of ZFS deadlocks. And we ended up a lot of time with a problem with ZFS, which most of them and all of them has been fixed recently. And it's very good as a test tool for DFS. For example, someone added recently, updated ZFS recently, and you can see on the FS mailing list that quickly after that someone came up and hey, Poudriere is broken now because Poudriere is stressing so much ZFS, and we figure out corner cases you can't get most of the time. So if you're working on ZFS, you want to make sure that your filer, your storage, whatever is stable, run Poudriere on it, and you will make sure that if Poudriere passes, it will support everything. We got problems also with TMPFS that will be fixed in the meantime, NullFS, some deadlocks as well. We figured out, because it's mostly designed in shell, we figured out a lot of issues with shell, so we improved a lot shell, in particular in job control. Well, we improved. We harassed the maintainer of shell so that he fixed shell for us, and there was a lot of fixes that happened in FreeBSD 10 and 11, and it highlights a lot of contentions. Just looking at what the system is doing, you figure out that, hey, I'm not using many resources for building, something should be doing something else in the background, and then you figure out, oh, I have a contention in the VM here, I have a contention in the network here, I have a contention in the file system here, and then you try to figure out people that are expert in that area and say, hey, can you please have a look at that? This part didn't work very well on FreeBSD yet. Some people are using that in that direction, but I would love that they do that more. So please use Poudriere, please run all the tools you know to debug dtrace, PMC start, whatever, and look at the contentions. It will highlight a lot of them for you. On Dragonfly, on the other hand, they took a lot of time to do that. So they decided to go through package a long time ago. So going through package, they decided to go through Poudriere as well. They forked their own version because they don't have jails. They use Hammer instead of ZFS. And so they have a branch inside the Poudriere so that they still live together. And what they did is, it was used as a benchmark tool by François mostly 2 years ago. And they figured out, yeah, okay, we're pretty good, but we can be way better. They also used it as a stability tool. They figured out a lot of issues. There was panic all over the place. So the first time they started Poudriere, something like less than 5 minutes later, there was panic. Same happened on FreeBSD at the beginning. And you can end up into having to fix systems that you thought that were stable for like forever. Like I don't remember, for example, it was the TTY layer what you figured out.
We had like a 20-year-old rest conditions TTY layer.
So because you got all those jails trying to speak to the same TTY at the same time, you end up with race condition here, and so you can figure out bugs everywhere in your system. For example, I just as a side note, I made a Poudriere-like tool for Linux once, and I think only X2 was able to survive without panicking. I haven't tried on the recent version of X4, but X3 and the early X4 were broke very easily in that case. And so they improved a lot on Dragonfly, the scalability on very large multi-core, so you get graphs after that. You can check the mailing list on the FreeBSD package mailing list. François sent a mail with this, and so there's a lot of mail happening in 2013, 2012 on the Dragonfly mailing list about all the fixes they did. And Matthew Dillon had it attack Poudrière in front of all the commits that were fixing things figured out by Poudrière. So if you want to have a look at what you can fix or improve based on just analyzing what Poudrière is doing on your system, just have a look at what they did back in the time and you'll figure out you can improve a lot of things in a lot of areas. So this is an example of what happened on Dragonfly. So this is graphs from François. And so you can see on 8 cores, you don't see many difference. You're okay, it's cool, I got small improvements, still better to have. But as soon as you start to scale on 48 thread system, then you can see the difference is huge. And this is 3 months work of, I would say 2 or 3 people. Well, people that knows what they are doing, obviously, but 2 or 3 people. And in 3 months, they improved a lot scalability. So, of course, on the right side, the higher the pick is, the better it is, and the opposite on the left side. So this is the build time in minutes, I think it's per package, if I remember properly. And the other one is the number of packages you can get per hours. So imagine on the cluster we could be back again on the 12, on almost 12 hours for packages if someone does that work. Okay, so I've designed a bit how all this stuff works. I'll get not that much, but a bit on the design, on how we make the code. So what happened under the hood. So it's mostly coded in shell. So people call me crazy because I use shell. So 2 reasons for that. I need the base system only. Second is, if you know the tool, if you know how to do it properly, and you know everything we get in the base system, you can do very maintainable stuff. Yes, it's possible in shell. And have a look at the code of package. We spend a lot of time to, the code of Poudrière, sorry, we spend a lot of time to isolate function, make simple things, and we ended up with a maintainable, quite easy to get in shell script. And it's not that big. It's quite small, actually. And all the alternatives I've seen were on FreeBSD, I mean, Python port building system, Perl port building system, whatever. They all ended up with way, way, way more complex code than what we get. And less features, and probably a lot more line of code. Still, we have some bit of C. Not that much. We added some bit on C when the binaries from the base system to do the same thing were too heavy. You have to keep in mind that we are running this in parallel multiple times. Like for example, if I want to check if a directory is empty from the shell, I will do that thousands of times for thousands and thousands and thousands of packages. So if you can save 1 second here, in the end you have saved half an hour or 2 hours on your building. So that is important. It's not micro optimization. One of the cases where we wrote, which sounded the craziest in my opinion, to do that was how do you figure out if a directory is empty in an efficient way with the current tool? You use a find. You use find, you say, okay, find in that directory, that depth, never go over that depth, and couple of options, and is empty, something like that. Well, just opening the directory and reading, saying, okay, I have dot, I have dot, dot, I have something else, done. It's way faster. So that's one of the things we did. But we don't have that many like that, because most of the time the tools we have in the base system are pretty much efficient. We took a lot of care on the efficiency. So, as I said, if you want to do things in shell, learn shell. Otherwise, you will end up making subshells all the time, so you fork all the time. The fork has a cost, and this cost will end up into making your package building things longer. Actually, the techniques we use are also useful for all the shell script which is embedded into the port tree, because the same applies there. Because we run make, and make will run some crazy stuff. If you make them optimized, you improve a lot your building system. So parallelize as many things as possible, reuse resources as much as possible. So when we started, we created the jail, we're finished with that, destroy the jail, create a new jail, except you have the overhead of creating the jail all the time. So now, instead of that, what we do is we create the jails, one with network, one without network. We fetch in the one with network, and we build in the other one. And when we're done, we make sure that we clean up everything from that jail, but we keep the jail available. So we create persistent jail, and we avoid the overhead of creating and creating and creating again jails. We use the file system as a key value for a lot of things, like the queue, whatever. So in that case, we use TMPFS for speed, and I mean, we try to go to different direction, and the file system as a key value in that case was the faster. The other direction we will probably take is having that in memory into a daemon that we will create for that, just because we want to go distributed, so we want to distribute that, and the daemon will just make sure to remain, or we will probably just send this TMPFS on the different version, we don't know yet. But key value, when you get simple things on the file system, is often simpler to debug, simpler to get through, very fast, and more efficient than most of the key value you can find out there. Trust is your friend. If you're building, if you want to see if you're doing good things and you don't want to spend time on micro-optimizing this one and micro-optimizing this one, which are useless, or figure out, okay, I'm probably calling too many times this one, you want to just spend your time on optimizing the right thing, which is taking the right time. And trust you get, so you can go trust or detrust. I know Brian prefer detrust, I do prefer trust. And with those two options, you will get this table in the end of the build, and you will get one per fork that happened in your system. And you figure out, okay, those syscalls were called that many times. This one seems to be quite long to run. I probably try to see what is responsible for running that and reduce the number of calls for that. That's how we figure out that creating stopping jails was very heavy and we can use something else. So it is very important to take care of the tools you use, make sure you use efficient tools. A simple example of things not to do in shell. Well, in my case, I show something which is not really portable, set var. Well, the initial shell have it, but the POSIX doesn't define it, so you can use eval in that case, but that stupid difference makes a huge difference. So the thing is, in that case, you fork and then you get a subshell just to get the result of the function. In that case, you don't fork. That sounds stupid, micro-optimization, we don't care about that, but in the end, when we track that down, we reduce the build time from a lot when you go through the whole port tree of 25,000 packages. So, now you're doing that, you don't want to go through micro-optimization, but you can do a lot of good things, like please abuse exarchs. I mean, I've seen some build system, well, build framework like the port tree in other operating system. People just going through a loop and then, okay, remove that file, remove that file, remove that file, remove that file. That means you spawn RM thousands of times. Well, you can use exarchs. Please RM, spawn one, remove this bunch, spawn again, remove this bunch, and you end up with reducing a lot the overhead of the speed of your builds and the overhead of this target if it's a makefile, for example. Learn awk. Seriously, pipe grep, pipe set, pipe something. Most of the time you can do that in a simple awk. And you'll benefit from something else. With awk you can just do, okay, this field is exactly equal to this one, so you get string compare instead of having a regex. So use regex when you need regex, use that when you don't need that. Learn set as well. I mean, learn the tool you have in the base system. They probably do more things than you can imagine. They're all more simple than what most people imagine, and that avoids a lot of complexity because you get unreadable lines like long like this with a lot of pipes, a lot of forks. Learn your tool. You can play with file descriptor with shell. Play with it. I mean, we are paralleling stuff. We want to react as soon as something is done. What we do, we just make a file descriptor, having all the parallel version doing stuff, and talk back to your file descriptor. You just have a read on it, and then you can exactly run something at the end. You do it. It's easy. So the only problem we got is POSIX shell is limited to 10 file descriptors, and I think only FreeBSD is respecting POSIX on that because the other decided you can go further. It's okay. And set-e. I mean, you get an error, you want to control what happens, set-e. Seriously, use it, take it, trap the error, clean up stuff, report error to the user, you can get something very, very clean and very nice for the user. So, I think I'm in time, yes. So now I got packages. I got jails with kernel, and I got port 3. So to get an image of a system, it's just, okay, I've been everything, let's just take this part here, mix them together, and then, yeah, I got the live CD, I got MFS root, I got a RAM disk, I got the nano BSD, I got everything. And if I need to rebuild them, I don't need to go through the whole phase of rebuilding the world, rebuilding the kernel, rebuilding the packages, and each time again and again. So with Poudriere now, build a package as you used to do, and then in the end you say, okay, just give me everything you already built and create me this image. This is work in progress. This is how we do create now the VM, the FreeBSD VM for the Gandhi cloud, and this is going to hit Poudriere soon. We don't want to reinvent wheel, so we got tools over there. I mean, Crochet is doing a lot of stuff, NanoBSD is doing a lot of stuff. Get to them, figure out what they do, grab the code, make that into Poudriere, and then we get one tool that benefits from experience from the other and able to provide a lot of things. So right now what you can do is create an ISO. This ISO could be with MFS root inside or not. You can create USB stick. You can create just MFS root because you want to PXE boot. You can create firmware based. So firmware based is a bit like what was done with NanoBSD, where you get 2 partitions and you get one operating system in the first partition, another in the second, and when you want to upgrade, you just DD on the second, and then you set a flag to say, oh, next time boot on this one, and if it fails, then at the reboot, boot on the first one, because it might fall back, it was safe. So we do that, except that instead of using MBR, we use GPT, because it's simpler now with that. And that's all. We can also create raw disks, so you just have the file system on it and the operating system installed and whatever, and push that into your VM. What is planned is those raw disks we plan to do with MKimage, VMDK, VHD, all the stuff. And doing that was a matter, if I remember correctly, only 40 lines of shell, because we got everything already done. And I think I'm almost done. So if you want to get information, everything is happening in GitHub of FreeBSD. You can send pull requests if you want. You can do a lot of things. We got a channel on Freenode. You go -Poudriere and then #Poudriere, and then you will find me and Brian. So remember, now it's mostly Brian that deals with this. I'm just having fun in it and adding new stuff. And new stuff, new bugs, he fixed. Perfect. We got a handbook that explains how it works. So we got both normal usage and one bit more extended to explain how you do testing as a maintainer or committer with Poudriere. And that's almost it. Oh, one thing I forgot about everyone working on the sources. Poudriere supports -P when creating the jail. So you can just say, hey, please, take the vanilla head, apply this patch on top of it, build, create a jail with that, and then you can build your package yourself. So when you do Xprun now on the cluster, so those not familiar with FreeBSD, Xprun is people having patches for ports or for the source tree, they just say, hey, port manager, can you please build the full thing on top of that and see if I break something. And Xprun is just doing that now. That's why we are very fast now at Xpruns. Xpruns usually take 1 or 2 days, no more. And we can do a lot of Xpruns a month. But even yourself now, you can do your own Xpruns if you get access to a kind of powerful machine. Let's say on the cluster we use 24 cores, 100 gig of RAM, and that's enough to be able to run your own Xpruns. And it takes a day. Yes? Not that many. I think, if I remember correctly, 20 gigs, 40 gigs for the package stat. You get the size of the of the repository you get in the end, and therefore all the space you have, because everything happens in memory. So we do TMPFS, we take the jail, we clone it into memory, we do everything in memory. When it's done, you only end up with your packages. So it's just a matter of a bunch of gigs.
So it doesn't keep the build trees of all the ports under the build. So as a port is done, it cleans up the tree?
No. What it does is it start up, it clone the jail into a memory, it nullifies the tree, it will copy the package, the binary package of the dependency inside the TMPFS, get into the jail say, okay, install my dependency, build, make package, you're done. The package is extracted from there, installed into your repository, so that hits your file system. That's the first thing that goes into your file system, and then we will roll back basically the jail in memory, get back into a clean state, get to the next one, and do that again and again. So on your file system, the only thing you keep is the binaries that you generated in the end. So you don't need that many space. Here we are. Yeah. Kirk?
What's the move to try and get packages into the base system?
So the question is what the move to try the packages into the base system. We're working on that. The easiest way would be to go through that kind of tool to build the build system to create the packages, but that's not the less intrusive. The less intrusive is what we're doing now. So a couple of targets are getting added to the base system, so you can do make packages at the beginning in this build world, stage something, create packages. It's half-baked. I've totally broken the branch yesterday, but there is a release-package branch, and everything is happening there. We want to have this for 11. So during the dev summit, I just said that if I'm not able to provide to the users some package to test for January, I will push that for 12, because I want to get at least 6 months of feedbacks of people really using what we generate, and not only developers. But the target is still 11, to get that for 11. Any questions? Yes?
What was the thing about putting the kernel in the jail? You said you were going
Okay, so the question was, what is the thing about putting the kernel in the jail? And the answer is this. Because if I create an image, and I got my jail, so I take the jail, the binaries, I put that into my image, I clean up the stuff that Poirier added when he created it to get back into a vanilla version, and I ended up with a nice thing without a kernel. So I needed to add this kernel. What I forgot to mention here is to support overlays. So you can have this. This is a directory where all my configuration is, and Poirier will just take the content and push it into your jail, into your image, overwrite what needs to be overwritten. So if you need to get homemade, if you're thinking about making an appliance with that, all your specific stuff goes into that overlay. So in Gandhi, for example, to create the VM, we got default configuration files that we provide. So all those default configuration files, including rc.conf.d things, they're all in an overlay we have in our own Git somewhere. And so what we have to do is just each time we want to issue something new or have a bug fix is clone this overlay and say, create the new image, please. And last time I checked is creating an image with a ZFS root. Yes, because we can create image with ZFS root or create image with UFS. And create an image with ZFS root was the longest, is the one that takes the most time, and it takes 4 minutes. Creating an image with UFS is something like 2 minutes. Any other questions? Okay, thank you.
Okay, thank you, Baptiste.
So, yes? You got a question? Okay. So the question is, we're doing jails now, and are we thinking about adding beehive? Why not? I mean, the limitation we got is on the system you can build, you can have images for a lower version, but not for higher version, because if your new version of head depend on the new syscall, then you don't have it on your kernel of the host, you have a problem. So one solution to avoid that would be to create beehives machine. So I already talked to Peter Graham about using beehive for that, or at least providing a beehive. Jails is a technique, is a detail in the implementation. Like when they switch to chroot on Dragonfly, it's just, okay, go to that function, take the jail and out and put a chroot instead. So yes, it will be doable to do that with beehive. The overhead of the creation would be a bit complicated because I cannot pass this temporary file system to beehive. So that's why I've never done that, and that's why I'm eager to see beehive supporting sharing file system between the host and the guest. But as soon as we got that, then we can have beehive for almost free. So you can imagine keeping on the release like 10.0 and being able to run packages for 11 on the release. Thank you.
Okay, thank you everyone. Thank you, Baptiste. And here's your Swedish bread.
Thank you.
Depuis plus longtemps.
I'm sorry, bro.
There's been a problem with some of them running out of power, so I think I'll just turn it off.
Huh? So, hi. Hello. My name is Vadim Zhukov. I will be talk about things that probably some of you knows better than me. That's not okay, I hope. What I want to talk about is about restless network configuration, what it's bad in designing of, I think, many operating systems we currently have. Hi. And I will be giving some samples how this could be done on the OpenBSD example, but okay, I won't go too much forward. So what I'm thinking about, I'm talking about initially any computer was connected to one network. It was just a fixed connection, wired connection. It was usually a wired connection, and so there was no such problem as switching to another network. You somehow configured all the options, and you are done for end of life of this piece of hardware. Nowadays we have laptops, nowadays we have Wi-Fi, nowadays we move on, you start at home, you move by bus, by train using Wi-Fi, you go to the park and share Wi-Fi with your mobile phone, you go to work and use its local network. You will switch networks each day, maybe tenth of times a day. So how do you switch to another network in a typical BSD system? Basically, in one live system, you use some tools that each of which configures its part of network stack. You use ifconfig to configure IP addresses. You will use your text editor or something to edit resolve.conf and so on. Or you maybe call DHCP client in some networks, but in some networks you maybe concurrent, where you need to override some DHCP stuff you get from the provider, and so on. You always need to set up something. And when you set up something, you do this in many steps. That's bad. Because when you do manage some network connection, you do it this way internally. You do a lot of ASCTL calls to the kernel. one call maybe setting up address and mask, another may set up media options. In case of Wi-Fi, it gets even worse. That's just an example of what do you have to issue to set up a Wi-Fi connection to a Wi-Fi network. So you need to set up a network ID, web or VPA key, maybe power parameters. Sometimes you need to choose a channel. Sometimes you need to set up additional parameters. I won't go in detail. It doesn't matter actually. What matters is the big number of such calls you do. Worse, sometimes the same call could be used for a couple of times because your high-level interface, say ifconfig, does things step by step. So if you say ifconfig IWMO NVID EuroBSDCon conf Wi-Fi VPAK 1, 2, 3, 4, 5, 6, 7, 8, and so on. For each the keyword ifconfig will issue the different state. So what basically is wrong here? You exit your hotel where you spend the night and go here to the conference, where you are placed in between. You are not at the hotel, you are not at the conference. You are in the intermediate step. You can't say, I am a hotel, or you can't say, I'm already at the conference. You can't rely on the fact that you are in a hotel, or you can't rely on the fact that you are in the conference. You can't rely on anything, you are in intermediate step. And the big problem here that the packets will still flow. Every connection that you set up when you were in the hotel will be continued while you are moving on. Someone could tell, wow, cool, it's, I could continue to do Wi-Fi. No, you can't do Wi-Fi because you move to another network, you got a different public IP address, your connection won't work anyway. Your connection will drop, but you still continue transmitting your own data, data that you tried to send via previous connection via new connection. Sometimes that will eventually it will of course stop doing. For example, when you get a new IP address from another network and your routing table say no, packets won't go anywhere. But until that happens, some of the info you will transmit, and in case of Wi-Fi, it will reverse because it will be transmitted everywhere. What other operating systems actually try to do in regard of making network switching atomic? Cisco OS is good. It has some many advances, but we can't use it ourselves. So it's out of game. Recently, Windows version got a nice tool called MetaSash. It does a lot of, it allows you to do many cool things as a system administrator, but the APIs that it uses on the hood are awful. They are really awful. For example, I tried to find a stable way to bring interface up and down in Windows. There is no such IP that can do it reliably. There is no such IP. The most reliable way I've heard about was about emulating mouse clicks opening Windows. I'm not kidding. But the configuration your graphics user interface is good. Red Hat, Linux have many things that could make him enterprise. Usually when I get another Red Hat installation, I try to disable those things one by one until I get something manageable. Those network configuration stuff that happens there, it's basically the same as BSD network files, slash etc slash hostname dot something or slash etc slash afconfig dot something, depending on BSD version. But even if it could provide some sort of rollback, it won't provide fully atomic network switching. The best you can get in Red Hat Linux is, and also of course CentOS and all others. Basically, not only about AL. The best thing you can get is to edit all the config files, then do service network restart, and have all the network go down and then up. For laptop, that's more or less maybe fine because you are obviously at the console and could have something, but it's still somewhat over-engineered, I think. And the final was that I looked briefly. Sal6 has nice infrastructure for configuring network. But as I talked with a few people here yesterday, it doesn't work well with wireless. For many years, Sal6 didn't have wireless support at all, as I know. So I can't speak on the graphics part, how it's useful. So the first thing that I'm trying to move on is to implement some sort of network profiles that could be applied atomically. In particular, it will, of course, keep passwords, it will keep all the parameters related to wireless or wired crypto, and this could be even done such way that it will allow to upgrade the used crypto. For example, you switch to router from WPA to WPA2. But not otherwise. The problem is that while this is mostly useful for wireless networks, but wired networks could have some use of such profiles too. The problem is that when you plug in a wired network, you see what media 100 megabits per second, and that's all. What do some other operating systems do in that regard? They listen for incoming broadcast traffic and see who what broadcasts here. If they, for example, in case of Windows, see that some domain controller is broadcasting information about himself, it decides, we are probably in domain with that name, and we could apply options related to that domain, and so on. That's basically no way worse than listening for all the broadcasting that wireless access points do. You don't control what they transmit. You can only look at the network names and the parameters that they carry on. So maybe we could ever have two profile layers, one dedicated for wireless options that don't apply to wired connections, say network ID, and some options for wired connections that will also apply to wireless ones. Things basically could look this way. So you have, when you connect to home network, we detect that you connected to home network. You have link level profile same for wired connections, but more high level profile about which who are your neighbors is different. So when you come to your job and plug in the same interface to another network, you could see totally same media options, but different high-level profile. Like that, if you go wireless, you can have different link level profile, since network ID is a thing that lies in link level layer. Also, please note that WP could be used in two different options. For example, at home you may be fine with pre-shared keying, simple password, and with the job you could have enterprise solution involving certificates, involving 802.1x standard implemented. It doesn't actually matter. It will be all written in profile. Next thing, it's what it was all about networks that you do know. It's more or less simple. You see the network you know, you choose to trust this network and configure your own interfaces, your own system to go this way. Next interesting thing is about very active roaming, where you often meet unknown networks, unknown for you yet. What should you do in that case? What should your operating system do in that case? If it's say a network with no name, it's a wireless network with no name, but with not no name, but with a compatible enterprise key, maybe we could trust them, because since we trust certificates anyway, we could trust them anytime. But in all other cases, it's about all of the cases that you need in reality. The user of computer should know better, but you can't go just from interrupt context where you got the packet and ask the user to move on or not to move on. You have to, you may post some sort of notification that, hi, I see a new network. But how long will you wait? How do you wait? He doesn't know. But remember, the packets are still flowing. Some packets from you are still flowing. To give you a bit more details, so that's the current state machine of OpenBSD Wi-Fi stack. So you see here init state that driver enters upon configuration or reconfiguration, upon starting interface. You see scan state when where he put an initial list trying to find a network that it was configured to, and also when you aggressively searching for networks around at all. When we found such base station that transmits our network ID we were interested to, we go into our state. After successful ALF, we are going to associate state, and after successful association, we finally running. What I propose here is to implement a new network interface. The name could be, of course, change it. Network state, sorry, interface state. In that state, no traffic should be transmitted at all, and interface in that state should be kept until a special RCTL is issued. How does it differ from init state? It differs that init state tries to move on to scan state, and scan state tries to move on to out state, and so on. And in that state, where we're alive, we receive packets, we can see all networks around, but we don't act in any way. It will be good probably to drop all our current connections that went through that interface, and the decision will raise many questions. Like, for example, we have interface bound connections, those we could drop obviously, but for example in PF we default to non-bound interface connections, non-bound states, sorry. So we could either look at routing table and look what packets are moving through our interface actually, and drop those connections, or we could just drop all of connections except loopback, or we can't find any other way. Especially interesting case is the datagram sockets, which are not bound to any other site, but could send anything to anywhere. To move things here on, we have, as I said, we have to issue an EuroCTL that will say, kernel, I want this network, or I don't want this network. I don't want any network, you see. This application should get the list of applicable profiles that we already know, such a list of known Wi-Fi networks. Usually you use something like that to talk about this. List of unknown networks. Then this application should make some sort of decision. Maybe construct a new network profile from unknown network, maybe not. At that place, it could, for example, show to user the question, I see a new network, do you want to join it? You know such questions. But the main point I mean that during that stage, you don't have any packets going out from your machine. And only when user says, I want this network, only after that the auth and then association states, auth and then association states are moved on to. Now, after this operations on network profiles were done, kernel will look at the new list of profiles, so it's not just application could say use that exact profile. The logic for choosing profiles lies in the kernel, so one cannot change it arbitrarily. You could only give one or other description that will in turn make the kernel do the right, hopefully, decision. This could be a somewhat dangerous way. Why? Because the interfacing between kernel and user land becomes more complex. It involves a few different EuroCTLs and notifications going up and down, and that becomes in some races on its own. And remember, we try to get rid of races at all. Mostly what I said was about wireless. And if we remember about non-wireless interfaces, remember that they mostly don't have state machine at all. Very simple. They don't have that out phase, sock phase, and so on. So if we go that way, we'll need to either modify all our wired network drivers. That's in maybe non-obvious way. And given that some of those drivers have some sort of upstream that will diverge from upstream and cause merge problems later, that's bad. We could still limit all this work to the wireless layer. maybe it will be less available. Ideas are welcome. It's still subject to change, and I should probably say that at the start. I want to discuss all these issues. I want to hear any feedback, any ideas, because that's a really big change in each step. Each step adds many little, but it becomes very complex. What we do have already? The current state of code that I have, it works on wireless level. I tried to not to break the normal network. It works that way that to use such functionality, you enable a special bit on the interface, and then it becomes managed by kernel. You can't manually set network IDs or crypto params anymore. They will come from profiles. Profiles are loaded via special LSTL at any time you want. They could be loaded via either ifconfig or via a special application, doesn't matter. And then some sort of daemon I wrote monitors profile changes and performs some additional actions that should be done in, maybe in userland. That's how that's an example of configuration file for this daemon. We could run some commands. Of course, that commands, when we run some commands, we should remember that the state could be, state of interface could be changed at that time. So it's more like logging. One of the features of that such daemon could give you is automatic way of going through captive portals. We use this functionality in our Moscow metro, so you just open laptop, and some seconds later you could use Wi-Fi at the metro without having to open some pages, typing buttons, saying yes you are agree, waiting until the advertisement ends, saying yes I'm really agree, and then only working. Basically, that captive works using Perl script, which uses mechanized modular, WW mechanized modular. So this. So this implementation shouldn't be considered as final. It's likely to be go to recycle bin as well as two versions before. First one was userland purely, second one now we use a kernel. But it already has some bins that probably will survive. tried to implement loading and saving profiles during the fconfig, but since there was no consensus on how it should look, I could give you, if anyone is interested, 2 versions. What do I plan on? I plan to start with implementing such state where upon entering what will have drop to connections and stop transmitting anything. After doing that, we could slowly revoke our CTLs to allow running a bunch of commands in an atomic way. Basically, by interfaces in the state, you could issue any number of CTLs. It won't affect any of running packets, because those packets should die anyway. I was too quick. Yes, I was afraid that I would be wrong, and yesterday I removed about a quarter of slides. Probably that was not. So if someone has questions or any ideas, let's discuss them right now. I should thank many people that already helped me to move things on, and I was so sorry that I don't move on as fast as I could. So any questions? Yes?
Maybe I missed it. Why do you want to put the profiles into the kernel? I imagine if the user management would always do the following. First, tell the kernel to bring the interface down, just drop all traffic, then configure all the parameters and bring the interface up again. That would be raceless too.
So the question was why profiles are moved in kernel and not in userland. The answer is that when profiles are in kernel, you may be sure that they will be activated in the way you planned. Imagine that you have your daemon somewhat slacking, or have it removed, or killed, or have it stopped, or anything else. You may be switching one daemon for another and lost some of notifications. Even more, you could lose notifications even in normal operation under high pressure. So by moving things into kernel, we get rid of many such problems that kernel will manage itself. Since all those options should be in kernel itself, we could safely rely that they are already there. Was it?
Maybe one more question. The fact that I can just kill the demon and then everything will stop, all this magic will stop, I would call that an asset rather than a downside.
Yes, if you go into a confirmed state where you're waiting for moving on, right? You're talking about that?
No, you said it's better to move it into the kernel because that's fully automatic and the demon can't
die. See what happens. What's the way interacting between the daemon and the kernel? The current options are that daemon could get notifications about interface state via routing socket, and it could and the daemon could issue comments through IOCTL on some probably another socket. Both of those should be considered as a message sent from one side to other. Those are not fully synchronous. Fully synced because when you issue IOCTL, you maybe could start some long operation. Also, and when you receive notification from a kernel, obviously the kernel won't wait for feedback at all. It just notifies you, and at some later point it may wait for some sort of command. It will wait if it move interface into confirmed state, and it will move interface in confirmed state only if it can't choose network already. So if kernel sees a known network from already known profiles, it will move on without stopping anything. If it will go into confirmed state only if it doesn't which network it should connect to. If it doesn't have any trusted network. Does it answer your question?
I think I understand what you want to say. I'm not convinced that I would want to have that yet.
Mm-hmm. Thanks. Any more? Yes?
Have you thought of using a data structure like an empty list or a missing pack or something to, instead of having all the separate IOCTLs, it has all the information in one, so then you can erase that one?
The question is that, if I understood correctly, that why not to move all the information via IOCTL and not just issue? Yes, I was thinking about having a single IOCTL. The first problem will be that we have different kinds of network interfaces. You say that we could just use the different parts, only what we need in the structure, and ignore all others. Maybe we could move that way, but that won't fix the problem with flowing packets. So we need some state where we stop transmitting all data. And when yes, we could go without saving profiles in kernel in the way like you say. It's really a hard decision to do. So both variants have the pros and cons. Pros will be that there will be less code in the kernel, obvious pro. The con will be that the kernel will have less control about the logic. So does that answer your? Mm-hmm. Any others? Bytes, sticks? labs.
This is code from BSD.
Yes, I've implemented on top of OpenBSD, but general ideas are of course portable, and given that the wireless stack was copied from one BSD to other at some point in the past, I think there will be not that much changes to apply this code to FreeBSD or NetBSD. Yes?
How would your layering of profile levels work when you move from an unauthenticated Ethernet to an Ethernet connection where you need to authenticate with 100, 800, 2.1x? So you have some corporate wired LAN where you plug in your laptop and you have to authenticate against the wired LAN. So you couldn't use the same link layer profile as on your home Ethernet network.
The question is that that we will have doesn't is correctly. Sorry, I maybe don't understand correctly that when you have two different wired locations where you use wired connection. And both use both use 800 and 1.6 enterprise security, right? But I doubt that you use same certificates at both ends. So. Yes.
You said all the wires would just use the same profile. In this case, you have a wire network, but it doesn't use a different profile, just like different
it won't use a different low-level profile because on a wired network you don't have such thing as network ID, for example. And this authentication scheme, it requires some additional logic that runs inside link level, but isn't wireless specific. Yes, so it should be in a high level profile because this authentication could be used in wireless too. Any more? More clarifications? Ideas? So, thank you all.
Oh, yes. Yeah. It's always good to set up the
Oh, sorry. Sorry.
This is off. This is on now.
En utav dem fulladdade.
Okay, the developer.
1, 2?
No.
It doesn't.
Yes, it does.
It does?
Yeah, yeah.
So this is used both for the room, for the streaming, and later on for the recording.
Well, that's where the audio comes from.
I hate camcorders. They are so stupid.
Just wanted to let you know I'm going to have to wander out halfway through. It's not because I'm bored, but because I have to go sit on the question panel for the foundation. I'd rather be here.
If at least you will get the new stuff. What you miss in the second half is the technicalities, like code auditing with AFL and web security and such stuff. But you can look it up on the web.
Good.
If you are interested. Yeah.
Usually when I'm on an airplane and I want to, just have something to read, that's when I read that stuff.
Then get the PDF beforehand.
Yeah. Okay.
Sorry?
You have to change the fan.
Yeah, probably. Oh. Oh, yes. Yeah, looks like we're good to go. Yeah. Probably not useful to start before the time, no. Yeah. But it's nice to finally give a real talk at EuroBSDCon. I've talked 3 times at BSDCon, giving updates in 2011, 14, and 15. And now this is really going to be an overview covering it all. So I have given a tutorial last year and this year in very different styles, but never a research talk. What is that? Oh, I think I'll use it rarely, but when I need it, I'll probably use this one. Yeah, my last talk in Canada was fun. We had a fire alarm right in the middle of the talk, so we had all to go out, 15 minutes break while the fireman cleared the building, and then went back again, and of course the next talk was ridiculously delayed. Hope we will not have that again. Don't do it up there at the... Okay. So, welcome everybody to my overview talk on to the standard BSD documentation toolkit in 6 years. Okay, so you say I'll still wait 2 minutes. Good. That's fine, so I'll start with an anecdote. When, that's not in the talk actually, when Kristaps Johnsons worked here at, in Stockholm, actually not at Stockholm University, but at the Königliche Technische Hochschule, KTH, a bit south of here. In 2008, he had his personal programming projects, and of course he wrote man pages for his personal programming packages, and he also put up the man pages on the web such that people could see before downloading his software what it was all about and how it worked. And he wasn't satisfied with the HTML he could generate from man pages, so he thought, okay, I'll write just a little program in a weekend for better HTML formatting for my personal web pages, and that's how ManDoc all started. So from a toy project for a personal homepage to the documentation formatter in FreeBSD and OpenBSD and NetBSD and Illumos in 6 years. Yeah. Okay, now really we have 2 o'clock. So again, welcome to my presentation on my overview presentation on Mandoc, called From Scratch the Standard BSD Documentation Toolkit in 6 years. Today I'm covering 5 topics. I'm giving a short 10-minute intro about the why and how. Why do we do manuals? How does it work? Where does it come from? Then a main part about Mandoc from the user perspective. How does searching work and all that stuff. In particular, I'm focusing on the things that are new last year or this year. There is a third part, more technical, about software engineering, how it was designed, how it was implemented, and system integration, how we got it into the operating systems. A fourth part about the ugly things like code audits, bug fixing, web security, and finally a conclusion, a summary of the status in the various BSDs and an outlook into the future. So, what is documentation all about? How does good documentation look like? Well, 2 things are completely obvious. The documentation needs to be correct and complete. Unfortunately, even that is often violated. What is even more often, can someone open the door, please? What is even more often forgotten is that documentation needs to be concise. It's not good when it's very long and you lose a lot of time reading it and have forgotten half of it when you arrive at the end. What's also bad is if it's scattered all around, part on the web, part in this directory, that format, part in another directory, another format. To be helpful, it really needs to be all in one place, easy to find and easy to access. And of course, it shouldn't be just plain text. It's better if the function of words is marked up, like this is a function name, this is a command line argument, this is a cross-reference, such that you can have it marked up in the display and can search for it. So, for the reader, it should be uniform in display and style. For the writer, it should be easy to set up, easy to edit, easy to maintain. Remember, without documentation, code is unusable because you don't know how to use it. So bad documentation is about as bad code in the first place. Yeah, it's even worse. If it's hard to write, developers won't write it, so you have nothing to read. But I'm talking about the Mandoc toolkit now, so let's also look at the developer's perspective, at the author's perspective of the document. No, wait, not yet there. The reader has one comprehensive tool now, the man program. And whenever you call man, it does whatever options, it does 3 things in sequence. It finds one or more manuals, either in a file system or in the database. It transparently calls a formatter on them and then displays the formatted text, typically in a pages. So far, that's quite usual and may seem trivial, but even in this easy area, there's been quite some progress last year and this year. We now have a simple user interface, unified user interface, that where traditionally we had various programs, apropos for searching, man for steering, nroff or mandoc for formatting, and all those had different options. Most importantly, since last year we have semantic searching for pages in production in OpenBSD, now also in FreeBSD. And since this summer we have semantic searching within a page. I will later show more details about that. And the same functionality is online in the MAN CGI, also based on this toolkit since last year. So now the author's perspective needs to be, for the author, needs to be easy to write, to diff, to read and change, should easily support semantic markup, produce various output formats, and be portable. And fortunately, there is one simple versatile language assuring all that, and that's the MDoc language, which has a long tradition. The basic syntax, the basic ROF syntax, had its 50th anniversary last year because Jerry Sal6 started it at MIT in 1964. And on that basic syntax, the classic MAN documentation language that was first used in AT&T V7 Unix was already based, and then 10 years later, Cynthia Livingston, on a Usenix grant, invented the MDoc language for 4.4 BSD at Berkeley, and she did a tremendous job. She implemented the language, she translated all the manuals for BSD to it, reading out all the AT&T proprietary content, rewriting from scratch what was needed. And nowadays that language is implemented both in MANDoc and in Graph. And that MDoc language is used by default now in OpenBSD, NetBSD, FreeBSD, Dragonfly, and Illumos. The main step forward with that language is that it has considerable expressive power for semantic markup, while the older MAN language is a presentation level language only. So in MDoc you say this is a function name, this is a command line argument, while in MAN you say make this bold, make this italic, and so on. Besides, which is also important, is that the MDoc language is self-contained and complete. So if you write documentation in MDoc, you only need the MDoc macros. Whereas when you write documentation into the older MAN language, which in Linux, where people still do if they write manuals at all, you always have to mix the high-level MAN macros with low-level ROF formatting, and it looks very, very confusing. Portability nowadays is no longer an issue because there are still a few very old-fashioned systems like commercial Solaris who still don't have the MDoc language in base, but when you distribute portable software, you can just convert to MAN and distribute with the MANDoc toolbase and distribute both versions. So to summarize the ROF input syntax, the MDoc semantic markup, and the MAN presentation format are really three things that have proven timeless by their simplicity and efficiency. And many have tried, but nobody have come up yet with better basic concepts. Those concepts that have been tried have mostly failed. For example, Eric Raymond and RMS have agreed recently, last year or something like that, that they will retire the GNU info format and replace it by something else. Now, it's fine that we have a good formatting language, but of course if you have a language you also need the toolbox to handle it, and that is now available in the MANDoc toolbox, which is functional in the way that it's all in one binary. It supports finding the manuals you want to read by file name, page name, word, substring, regular expression. It supports semantic searching by keys, both across and inside pages. It implements both traditional languages, also the table and EQN languages are almost fully supported, and there is even some support for legacy content in low-level ROF. It supports ASCII, UTF-8, HTML5, PostScript, and PDF output. It allows MDoc to MAN conversions for portable software, and it includes all the traditional utilities. It is completely free in the sense that it is ISC BSD licensed with no GPL code inside whatsoever. It's lightweight in the sense that it's ANSI C and POSIX and no C++ code inside whatsoever. Remember, Graph is written in C++. It's portable, it's small, even though all this functionality is contained in one binary. The binary, which is not the case for Graph, the binary is only half the size of Graph, and it's fast. Graph is a very fast system for typesetting, but for MDoc manual formatting, MANDoc is about 5 times faster typically, while other toolkits like ASCII-Doc DocBook, which is about the worst that is available in almost any sense, is about 20 times slower than Graph for typical applications. Now, let's get to some fun stuff, searching for manuals. You certainly all now know the apropos command by Bill Joy, that he started in the very early days of BSD, where you say a keyword and then it searches the title lines of manual pages. Of course, in the MANDoc implemented MAN, all that functionality is retained with all its options, but you can do more now. You can search specifically for any of these things. For example, you can search for a word as a function name, or as the type of a function argument, or as a file system path, or as a variable name, or an error constant, or an author name, or whatever. And you can join that even with AND and OR queries, so you can ask things like, which POSIX mandated function returns values of this or that type? Or what did this or that author write in section, which tools did he write for section 8? Stuff like that. Here I'm, at the top I'm giving an example. I'm asking which tools use the environment variable user, and then it gives me a list of matching manual pages. That's already available in OpenBSD stable since last year and in FreeBSD current since this year. By default, if you search for multiple things at once, it will be ORed. Optionally, with a command line, writing the command line in the wrong way, you can also use AND and parentheses. If you don't know all these macros quite well, you can also search for a keyword in any of the macros. The difference is the traditional apropos only searches in the title lines. It is not a full text search, so what I'm doing now, you don't get many false positives, but it searches across all the marked up content of the manual. And regular expressions are supported with just a minimal change in syntax. Now, we've got one step further. We've integrated the manual viewer and the manual formatter into one single program. That has quite a list of advantages. The main advantage probably is that you only need to learn one user interface. They both now have the same options, so less to learn. And each one can now use the options that were traditionally only available in the other one. Like you can do an apropos search, and you can tell it, oh, but please don't just give me the title lines such that I need to type MAN again. Give me the full pages right away. Or you can, the other way around, when you use the man command, you can say, and I want the output not as terminal output, as ASCII, I want the output as PostScript, and you pipe it into Ghost View right away on a single command line. So those are benefits. There are more. I'm not going through all of them. All this functionality, in particular the complete search functionality, is now also available on the World Wide Web. So since about a year, the OpenBSD website has man CGI as a C program linked, again, the mandoc libraries, and you can type exactly the same queries that you can type at the command line into the website. So that's consistent. Of course, in HTML output, you get hyperlinks in addition to what you are used to. Okay, now I'm getting to a very interesting part. This is now stuff that is really shown for the first time, that also has never been shown in Canada before, because it was completed basically 2 months ago. Imagine you are opening a huge man page. Let's actually do that. The terminal here, I type man k-shell. Now what I actually want to do is, how does the wait command in k-shell work? So what you probably do in such a case, you type the slash for searching and then say wait.
We can't see that.
Oh, sorry. Thank you for telling me. Yeah. Better now. So slash wait. False positive. Go on. False positive. Well, you see the pattern. So let's try again. What I say now is use a tag, like as if you were using the ctext program, wait, and it jumps right to the definition of the command. Now, that's what I call internal semantic searching. However, this functionality is linked to a lot of similar things. We have to, when designing and implementing that carefully, we have to think of it as a multidimensional task. There are different kinds of linked targets that you might want to jump to, different kinds of linked sources where you get the link from, two different link distances, different jumping mechanisms, different output media. What is this all? Let's go through it one by one. Link targets, the places where you might want to jump to, obviously are sections and subsections, but also syntax element descriptions. You might want to jump to the definition, the description of a function name, an internal command, an environment variable, an error code, and so on and so forth. Or link targets could also be anchors specified by the document author. Of course, that should be used sparingly, because the less the authors need to specify explicitly in the pages, the better. Then they don't need to learn new syntax and type new syntax. But occasionally it might even be useful to specify a link target explicitly. Link sources could be explicitly set by the author, so the author could explicitly link from one place to, say, the definition of an environment variable. But better, they should be explicit. Whenever a syntax element is mentioned in the page, it should automatically generate a link to the definition of that element. Or it could just come from the reader's mind. The reader reads the text and thinks, okay, now I would like to know that, and just as I've shown you, jump to another place. The link distance can be local in the same document, or removed to a different document, to a different manual page. The jumping mechanism can be search style. You just type in another name, or it could be hyperlink style. You have a marked up entity and you want to click on it. The output media could be terminal, HTML, PDF, whatever, and obviously on the terminal and in HTML and PDF, such linking will work differently. So, for example, on a on the serial console of a server, we certainly don't want to be asked to do mouse clicking. And in a graphical browser, you probably don't want to type in link numbers to follow a link. So yet we do want all this to work consistently across all media. So it's crucial not to jump to an implementation and do it too quickly. When the first specific proposal was made, what was proposed there would have doubled the number of macros in MDoc and required substantial rewriting of all manuals. And that's not the way we are going to go. So, what was done so far? Before I started, the state was that local explicit links were supported only and only to sections and subsections, and they were only working in HTML output mode and only in linking mode, not with any search functionality, except of course searching for line start and a capital name. What I did this summer is I designed a way to work with lists of local targets. So far that is used for implicit targets only. So while the formatter is processing the manual page, it collects all the definitions of syntax elements like functions, keywords, flags, variables, arrows, and builds a list what is where, and that list can then be used for jumping. Even though this is very partial functionality, I think it's an important step to have such a list at all, and it's a logical first step, and you have seen that it's already quite useful. How is this implemented? First of all, it only does anything when you are using a pager and when at least one page is actually formatted. So when you're not using a pager, it's just using standard out, not doing anything at all, so it won't disturb your build systems. The first thing it does is set up two temporary files, one for the output, one for the tags, and one MarkSP style open hash table for collecting the information, and then during formatting, on the one hand, it counts the lines of output that must be done during formatting because we can't do it in the database because the user can specify different output widths, different terminal widths. And besides counting the lines, whenever it finds something interesting, it puts information into the hash table. In the third step, when formatting is complete, the tags file is written to temp. Then in the fourth step, the pager is spawned, which is less, passing both files as arguments. Then it waits PIDs for the user to exit the pager and finally cleans up the temp files. The implementation adds 14 new lines to the formatter, to the existing code, and one additional module of 240 lines. So it is not a lot of bloat technically, and it is also no user interface bloat because there is not a single new macro and no new syntax whatsoever. Quite small. The plan for moving on with this is to carefully and slowly extend along the 5 dimensions. So it should be rather simple to add more explicit targets, and we could maybe also add some smart heuristics, more than we already have. We could explicitly support anchor definitions by the document author. The other points, the other dimensions are more complicated. For supporting more links sources, we really carefully need to think about how to design explicit internal links to arbitrary targets, because that will probably need a new macro. And while working for the last 5 or 6 years on all this stuff, I've been very glad to deprecate at least half a dozen legacy macros, but I've never added one. I don't want to make this more complicated, so I will carefully think about doing that, but I think at this place it will be warranted once. The jumping mechanism needs a careful design, in particular for console hyperlinks. You're reading a manual on a console in a pager. Now what exactly do you do to jump to follow a link? That needs a careful design. And for the link distance, we also need a careful design for the concept of remote links. So if you say, if in the page there is something like one library manual page is talking about a function that is documented into another, in another page, it should link to the definition of that function in that page and not just to the other page, but that will probably need an extension of the XR, the cross-reference macro, so that needs care. And output media, of course. So far, even though HTML is easier with linking than terminal, I've only implemented this internal linking on the terminal so far to get the difficult thing out of the way first. Needs to be done for HTML too, now that it's proven that it works on the console. Okay. So far about searching, but from the user perspective, searching is not the only thing that was improved during the last 1.5 years. One thing that was improved was the representation of equations. Now, fortunately, in the base systems, there are very little mathematical equations in manual pages, but there are areas where that is relevant. For example, in X11 manuals, when it's coming to graphics, you have a lot of matrix manipulations. So there are some pages that do use it. There never was a problem with parsing EQN code. That always worked quite well, but representing it is not a trivial problem. Kristaps very nicely solved that last autumn by using first moving all the HTML output to HTML5 and then using the MathML language for equation output. And I addressed the terminal. What GNU EQN does is try to represent mathematical formula by moving up on the terminal stuff by a line or down a line or printing stuff on top of each other. And you can imagine that doesn't really work out. It's almost illegible. So what I've implemented instead is a linear representation of equations. So if you get, for example, a fraction, it will just be printed like this, or if you get a matrix, it will just be printed like that. I admit that's very far from nice, but at least it's intelligible, so you can grasp the content. That was about 125 lines of straightforward code, but designing it and had to be done. Yes, that is maybe possible, but it would have to be done in addition, because we also want to continue supporting pure ASCII consoles. Yeah, but there is another point where that could be done, that is in representing tables. There you can also use Unicode characters for like borders and so on. It's not done yet. Another thing that was improved in 2014 is multi-byte character support. So imagine you have a Japanese or Russian manual written in UTF-8. What Graph does is it calls a preprocessor, transforming those UTF-8 characters into ROF escape codes, and then feeds that into the formatter. What we have done and you need to remember to add the option to the manual or the Graph command line saying that this does contain UTF-8, otherwise it won't work because the preprocessor won't be called. So there are traps for the unvary. What we do now is we need absolutely no options, it just works because one thing. I've integrated UTF-8 input handling into the Mandoc parser itself. UTF output works anyway for a very long time. And I've implemented automatic character set recognition in a very simple way. So if it looks like valid Unicode, it's formatted as Unicode, and otherwise it's formatted as Latin 1, which works surprisingly well. So basically reading Russian or Japanese manuals is no longer any more difficult than reading English ones. Suppose you speak Japanese, of course, that is. Yeah. Okay, let's perhaps... One other thing about the user experience is getting errors and warnings right. Until beginning of this year, it could happen that if a manual was severely misformatted and had really, really bad markup, you called the formatter on it, and the formatter would exit and say, this is so bad, I can't do anything with it. I can give you no output whatsoever. That's of course bad, because it will annoy both authors and users. That can no longer happen since this January. I've fixed the last cases that threw fatal errors, so whatever crap you throw into it, it will now at least produce some output. Of course, garbage in, garbage out as always, but it won't give up. I've spent surprisingly large amounts of times repeatedly at improving the quality of error and warning messages. The point is this: if an error message is missing or is too generic, then authors have a hard time finding the problems they introduce into manual pages. So you basically steal time from authors. Think about tech error messages and stealing time from authors. If a warning message is missing, authors write code and don't even realize that it's maybe not portable or is a bad idiom. On the other hand, if there are too many warnings or they were too prominent, people get annoyed at them and just switch them off. Some people think that you can get around this problem by adding a knob or two knobs to select the level you want, but that's a bad idea too, because if you add too many knobs, users won't remember them and won't use them, and you are back to square one. So, and by the way, all these problems in the beginning happened in Mandoc. We had too few and too many error messages all at the same time. Now we have settled at the system where we have exactly two user-relevant error levels. One means this is not good style, and one means this will probably, that's called a warning, and one means this will probably format badly, that's called an error. Okay, one short remark in between, because we are talking about authoring man pages. In case you ever need to write or fix a manual and wonder how to do it, the most important resource that you should look at is the MDoc manual. If you wonder which sections information to put into, look at the manual structure section. If you wonder which macros to use for a specific purpose, look at the macro overview section. That's just 50 or 60 lines listing all the macros that exist in the logical order. If you have settled on using a specific macro and wonder how to do it, look at the macro reference section. Then look at the OpenBSD base system for examples. Helps tremendously. And I just recently walked over all the OpenBSD pages, 5,000 or so again, and I can confidently say that they are all using everywhere a good and modern style. So anything you find in OpenBSD base system manual pages is good advice. In FreeBSD, it's probably about half the pages that are good advice, and some have slightly old-fashioned syntax in some cases. mandoc tlint is very important. It catches most syntax errors and provides some hint on style. So once you have something, run it through tlint. Yeah. And there are a few more resources. Of course, if nothing else helped, just mail to the discussion mailing list at mdocml bsdlv, which is the portable mandoc site. Okay. Still, user perspective. Imagine you are maintaining a portable software package. Of course, with your software, you're providing complete and correct and concise and marked up documentation. However, you want it to be portable everywhere. So which language do you choose? In the past, that was a problem. You couldn't just use mdoc because then you were lost on systems like commercial Solaris that simply didn't have that language. Now, just use the mdoc language, and before building your tarball and distributing it, run mandoc tman on your mdoc page. It will throw out a man version of the same page that will also work on commercial Solaris, package that together with the rest, and then let the configure script decide what to install on the target system. If mdoc is available, install mdoc. If man is available, install man. If nothing is available whatsoever, you can even let it install a formatted version. Of course, there is also the reverse program. The guy who talked just before me, Vadim, is a great porter in OpenBSD working on foreign software, making it run here. So the slide before was about you write software, wanted to run everywhere. Now you collect software from everywhere else, want to read the documentation. The problem with it is that Graph is the by far most used program for showing documentation, and it has a lot of features, and there is the law of feature creep. If some software offers a feature, sooner or later someone will use it. And there's a porting corollary. Even if a feature of the raw language is completely irrelevant and useless for manual pages, sooner or later you will find a third-party software abusing it for manual pages. So mandoc can never be a complete nroff implementation. And so in ports you cannot say mandoc or nothing, because then some manuals will get misformatted, those that are using the really arcane and useless features. It's not that many any longer. So in the OpenBSD ports tree, 95% of ports manual just work with mandoc. But what about the remaining 5%? The OpenBSD way to solve that problem, mostly devised by Mark Espy, who is doing a lot of work on our ports tree, is to mark those 200 that remain, that still need graph with a variable, use graph, in the port makefile, and then during the port's build, pre-format the manual and package the formatted version. Otherwise, if the manual is fine with mandoc, package the source such that the user can profit from semantic searching. The advantage, of course, is this works perfectly for all manuals. The inconvenience is that porters need to pay attention and set that variable where it's needed, and it needs a bit of infrastructure, but we have that. Okay, so far about using mandoc. Now I get to a bit of the design of the implementation and about system integration. So the question here is really how was it done? How was it that it became a success? the MDoc language, in a certain way, is a really nice language. It was developed at almost the same time as HTML and has the same concept of a block structure. So, for example, you can have a block of optional syntax elements, and it may contain submacros that again are blocks and so on. In ROF, all that is thrown away in the following way. When ROF starts formatting such a page, it translates the high-level structured requests into low-level physical formatting instructions and then outputs them on the respective output device. On the terminal, not much of a problem, but if you want to generate HTML, by the time you come to the formatter, you have already lost all the structural information, while Mandoc retains the structural information and is able to actually put classes into the HTML elements in HTML output. However, ROF is also an ancient language, so there are some gotchas. For example, some manual pages use so-called badly nested blocks, which means that the author starts one block A, starts another block B, and then closes block A while block B, that is inside, is still open, and closes the inner block only after the outer block. You can actually see here how such an example would look like when formatted, and that's actually how Groff formats it and how Mandoc formats it too. Our first thought was, oh, that's an abomination, we will deprecate it, will people tell people to stop doing that, but that didn't work out because there are quite a few manuals using that, and there is no way to change all manuals everywhere. Remember, we didn't want to have Mandoc for OpenBSD only, or even to change the habits of all authors, so reluctantly, we implemented that. It gets even worse. While I told you that the MDoc language in principle is self-contained and you can do everything you need in it, still there are some people who either mix in low-level ROF instructions because they could in the past, and there are still legacy MAN manuals, and they have low-level ROF instructions mixed in the first place. So some low-level ROF had to be implemented, but we did that later. That approach actually turned out to be right. Starting from the high level gave us a clean design, and then the reluctance to do the unclean low-level stuff kept us from getting off track. In the beginning, the structure of the Mandoc program was basically have a main loop for iterating over all the files, and then for each line of each file, look which macros are in that line, push them into the parser, which converts it into a syntax tree, and when the syntax tree is ready, pass the syntax tree to a formatter who will iterate the syntax tree and generate some output. Yes?
How can you represent such badly nested blocks in a tree? Do you generate split the overlapping interval?
So the question is, how do we actually represent badly nested blocks? What we actually do is, physically, the whole B block is contained inside the whole A block, and after this BO, we insert an additional element that says the formatting of the A block stops here, but not the block itself. It's a technicality, but that's how it's done. Yeah, so how did we get in a bit of low-level ROF support? Well, after before the first step of parsing each line of input for macros, we inserted a call to a ROF preprocessor. interpreting the low-level ROF stuff, doing something with it, taking it out, and then passing what remained on to our normal parsers and formatters. Now that might seem strange because it's putting all the concept of the language topsy-turvy. What ROF does is expanding high-level macros into low-level requests and then formatting them. And what we do is first get rid of all the low-level requests such that only the high-level stuff remains and then formatting that. And at first you would think that can't work at all. It's starting from the wrong side. However, it does. And the reason why it does, I think, is that what is essential about manuals is the high-level structure. So that there is some low-level stuff mixed in is just a smaller side effect. So actually our way is at least just as logical as the other way. Of course, this concept won't work at all in general typesetting because there it's completely different. There the low-level stuff is not just a side effect. So sometimes it's possible to put a concept really all the other way around, but only sometimes, not always. By 2011, we had reached the stage where we could say, okay, it just works, and where we enabled it in OpenBSD, basically after 1 year of working on it. And then we said, okay, now you other systems, if you want it, if you think this is viable, just grab it. You can do the same as we did, only with less risk and with more support. And basically that's what happened. NetBSD integrated it 1 year later. FreeBSD finished the integration, almost finished the integration last year, this year. Yeah. So one of the most important factors for success was that we moved fast. We didn't let our staff use a rot in some corner, but as soon as we were confident that it could maybe be usable, we put it in, we switched it on, we kept moving fast, we didn't fear change, and when something broke, we quickly fixed it. Of course, if you put in stuff into production that's just finished, then sometimes things will break. You will have forgotten something. In that case, what we did is quickly implement a fix, the quickest fix that was available, put it in. People were content again, could read their manuals. And then we started thinking, okay, how should we solve this? Took a few weeks or even a few months in some cases, devised a proper solution, ripped out the quick hack, put in the proper solution, and we're glad with that. We did that at least 5 times, a list of examples here. Now you might think, oh well, that is inefficient, you code everything twice. But no, it's actually a very sane and efficient way. The first implementation explores the feature. What is it exactly what we need to do? And the second implementation then gets it right. And that's particularly a good approach in complicated cases. And those that go wrong in the first place typically are complicated cases. So that's not a bad way to get on. So a summary of that is, we started coding with a nice high-level stuff that gave us a very clean overall design. We etched in some low-level ugliness native, but just where it was required, not everywhere where we could do it, even while the tool was already in production. And that changing parts of the design after the fact was only possible since we kept everything small and simple. Otherwise, when you build a gigantic framework with lots of layers, such stunts would break everything if you try to change the design after the fact. So it's well known that complexity should be shunned for 2 reasons, because complexity is adverse for correctness and for security, but actually there is a 3rd reason why simplicity is so important. It's also important for flexibility, and that in turn is important for being able to get on, to move fast, and to get new stuff into production. So that was probably the most technical part about the system integration. Now what happened last year is that this very dangerous predator approached our code. Jonathan Gray, one OpenBSD developer, helped him and weeded out lots of bugs from Mandoc. So of course I should say a fuzzer is a program that feeds another program crap in the hope to crash it and to uncover bugs, in particular security bugs. Jonathan Gray with the American Fuzzy Lob program found 45 issues grand total. That's enough for allowing a quantitative but not a statistical analysis. A third of these bugs were violations of invariant. A third were due to excessive complexity, partly in the languages, partly in implementation. And the rest were standard things like missing input validation, buffer overflows, use after free. So there were a few lessons from that. Obviously, the most important, keep code small and simple. Simple because quite a bit of this was due to excessive complexity. But then also paying attention to the simplest sources of bugs, like input validation, buffer overflows, use after freeze, in such a real-world setting, may get rid of already, with relatively easy auditing, about a third of the potential vulnerabilities. And also a lesson is that OpenBSD is certainly not a project that is famous for sloppy programming. And Kristaps is certainly not a programmer who is incompetent. So even when people who are moderately skilled programmers in an environment that is doing a lot for security try to code up something, then you still get considerable numbers of bugs. So auditing and re-auditing is really important. Slightly later, Sébastien Marie audited the web manual viewer that I've told you about. And at first I thought, oh well, what's the point? It doesn't even have authentication. And come on, what is the risk here? People reading manual pages who shouldn't? What's the point? Well, no. The point is different. It is running on Bob's server. And if it's doing things it shouldn't, it may burn resources. It may reveal information from the server that was never intended to be revealed. And Sébastien found various things there. For example, missing input validation leading to seg faults, or unvalidated input, like from path info as query string, leading to information disclosure. Being able to read arbitrary files, or invalid characters in the input from the user that would lead to XSS vulnerabilities. So the lesson from that was, whatever web application you are writing, you should always consider it security critical, even if it doesn't do any authentication and even if it doesn't contain anything but public information. It's really worth looking at. Performance, I'm mostly mentioning that to de-emphasize it. Yes, There are situations where you have to look into performance. For example, my first approach to get all this into the OpenBSD build system resulted in making the build times longer on slow architectures, and that met opposition because developers said we don't want to hinder developers developing, we want to help developers developing, so it needed to be optimized. However, only start optimizing at the very end and only if you really need it. Most people start much too early, spend much too much time on it, and here we have a typical example of a thing that should not be optimized. With the old plaintext apropos, a typical search took about 10 milliseconds on my notebook. Now, the new SQLite-based approach has some more overhead and takes 4 times the time. That sounds bad, but it's 40 milliseconds, so not going to optimize a great lot there. Good. We're coming to the conclusions. What made this replacement project succeed? First, we started with a clean design and we sparingly added support for less clean, historically grown features that were needed. We quickly went into production and then paid great attention to user feedbacks to find and fix bugs and to add the real-world functionality actually needed. We improved step by step, aiming for complete functionality but avoiding bloat, and step by step implementing the real-world needs. The priorities were first, correctness and security, second, compatibility, third, simplicity, and fourth, performance, but in that order. The status summary, so where is this used now? It's fully integrated in 3 operating systems. So all the features available are used in OpenBSD, Alpine Linux, and VoIP Linux. It's almost fully integrated in FreeBSD current, mostly due to the work of Baptiste Darroussin. The only reason that the MAN program is not switched yet in FreeBSD current is that, and that's healthy, he doesn't want to change too many things at the same time. He wants to move in well-defined steps such that people don't get screwed. It's the default formatter in NetBSD and Illumos, but they don't have this powerful search applications yet. It's in the base system, but not used by default in Dragonfly and FreeBSD 10 and Minix. It's in official packages for FreeBSD 9, Arch Linux, and PKG Source, and there are unofficial things for many other systems. The commercial Linuxes have typically outdated packages, probably easy to update, but don't really use it yet. But systems like Alpine Linux have demonstrated for years that it's possible in Linux to completely rely on it and get rid of all the old stuff. Possible future directions. Work is in progress on a lot of topics. We are converting the LibreSSL manuals to MDoc with Christop's POP to MDoc tool that is related to this project but not part of it. I'm working on unifying the parsers, aiming for yet better ROF support to get possibly rid of those 200 last use GROF ports. We also work on improving automatic detection of unsupported source code. That's what FreeBSD uses in their ports tree. We can delete, if we want to, most hard links to manual pages because Mandoc is now doing that in a more efficient way in the database. Christaps is working on a converter of TechInfo documents to MDoc that can both be used for just converting the stuff once and then checking in the MDoc pages, or alternatively to do it on demand. But that's in an early stage. For a long time I wanted to get more helpful with MAN to MDoc conversions. That would be useful for getting legacy manuals to the newer format. So far the best thing that exists is going via Christop's DocBook to MDoc tools, so we would first convert to DocBook, not because you ever want to use that for anything, it's the worst software available in documentation, but because it can be used as a transition format. And of course I want to continue work on the internal search and deep linking that I focused on today. What is not yet started, and which would be a particularly cool thing, would be to support automatic semantic enrichment of Perl manuals, so of manuals written in the pod language, such that you could, in the same way as you can search for functions in base system manuals, also search in Perl manuals. Right now, the pod language is translated to MAN, and then you get no semantic search support, but I haven't even started on that yet. Okay, on the minute. So, I'd like to thank a few people. Of course, foremost, Cynthia Livingston, who implemented the MDoc language in the first place and translated the bulk of our manuals that we are all using in all BSDs. Then Christoph Johnsons for writing ManDoc. Jörg Sonnenberger, who is actually here, I've seen him, for contributing important code, in particular in the early phases. Mark Espy for doing the OpenBSD ports integration and lots of important feedback, also for the OHash library we are using. Jonathan Gray for all that AFL testing. Sebastian Marie for the same thing with MAN CGI, and then a lot of OpenBSD developers who helped, in particular Jason McIntyre, our main manual maintainer, and lots of other people. By the way, all these slides are up on the web from all my talks, so if you go to the OpenBSD MAN homepage, then here in the bottom right, besides OpenSSH and LibreSSL, you have a link. We don't see it. It's off the screen. Oh, it's again off screen. Thank you for noticing. Now you see it. Yes, here right besides OpenSSH and LibreSSL, you have a link to the ManDoc homepage, and here you have a press and media coverage page where all the talks are available. Yeah, and then there were several people who contributed source code patches from various systems, Franco Fichtner, Dragonfly, Christos Tsoulas, NetBSD, and so on, and lots of people who have reported bugs and suggested useful features. Yeah. So much. What would you like to ask?
Especially the extended search features look very nice. What would be required to take a BSD system and import that and replace the existing old man in a 10.something system?
So the question is, what would be required to replace MAN in FreeBSD and make available all those nice search features? The answer is to use all those nice search features, install FreeBSD current. Baptiste Darussin did it, it's available. He also is able to integrate MAN, it needs very little, basically switching a few things in make files and configuration files. The only thing he doesn't do it just yet is, as I said, to not alienate people by switching too many things at the same time. If you want to do it manually to use the MAN, it's probably sufficient to just move the existing MAN shell script aside, rename it, and then make a hard link from the existing ManDoc binary to MAN. That should be sufficient to make it work. If you type MAN after, I didn't try, but I wouldn't know what else to do. And then you can create, if you want to, a etc MAN conf file in the right format if you need any configuration, like adding another directory. Yep. There is another question. Yes, that was a comment. Mandoc has been the default formatter for FreeBSD since last November. That agrees with what I... Yeah, you get Mandoc out of the box on FreeBSD current as the default formatter, not yet as the default viewer, but that is not as important for the user as the searching. Yeah. Yeah, Michael?
I have a small historic note. For those who caught Anders' talk on PCC, one of the many, many, many motivations for Mandoc was to resolve the problem of the fact that Graph was based on C++, so that if PCC was in base, you would not be tackling Graph.
Yeah. So Michael says that one of the main motivations for Graph was to get rid of the C++ dependency for Graph, which is true. There were a few more motivations. For example, reducing build times, base system build times was another motivations, because before Mandoc arrived in OpenBSD, we had to format all the manuals during the build with Graph. Now we don't format them at all, not even with Mandoc, but just install the sources. Yeah. It's right, I didn't mention all the motivations. I'm more focused on user features, yeah. Yeah. Okay, any more questions? Otherwise, thanks a lot for coming. Hope you enjoyed it, and have fun in the final session and a good way home. Oh, thank you. I like that. Okay, is this off now? No, it isn't. Is it off now? Yes. No. Okay.
The medal, how'd you do that?
Well,
Is that the fault?
it always looked like that. I don't know.
Okay. What's the model?
Oh, you have to press.
1 2 1 2 1 2. sådär, 1, 2, 1, 2, 1, 2, 1, 2. Jag ser, får du något ljud där också? So we're just doing a sound check, we're not starting really yet.
Jag bara en kort liten grej innan vi hittar 2 stycken kreditkort bredvid kaffeautomaten. Någon kan vilja ha tillbaka dem. Jag vet inte om det var för tjurhuset och de har gått förbi massa.
Ja, det kan det vara. Ja, ja.
Det var ju synd att inte säga till. Liksom.
Before we start this session, I just want to say that during these 2 days we have found 2 credit cards by the coffee machine and 1 set of keys. So I guess we can have kind of fun with yeah, we can auction them off later on, but if someone wants to purchase them for cheap beforehand, then I'm willing to make a deal. Now, when that's settled, I want to welcome our keynote speaker for the closing session, Patrik Fällström. Please give him an applause.
So thank you very much for inviting me, and to some degree it's a little bit embarrassing that I'm participating, because for some weird reason I have not managed to go to any of these BSD meetings, even though that is what I've been using during the years. I see lots and lots and lots of new faces in the audience, but also I see people that I have known since I started with Unix in the mid-80s. So, yes, embarrassing. But anyways, thank you very much for inviting me. Let's see what I can talk about. First of all, who am I? I was one of the people starting building the internet here in Sweden in the mid-80s. If I fast forward, I have been dealing quite a lot with white pages services, DNS, standards regarding internationalized domain names is my fault. I guess written too many RFCs. The last 10 or 15 years I've been very involved in ICANN, that deals with those top-level domains and stuff, and I will talk a little bit about that. I'm chair of the Security and Stability Advisory Committee of ICANN and been an advisor to the Swedish government. And during the last 11 years, this has been my motto. So this is approximately what I will talk about today. So, why are we under so much stress? I claim this is because we're in a new world. 35 years ago, in each country, we basically had one telco. They had some services. They came up with maybe a new service every second year. We paid an arm and a leg to use it, and we had one wire or transmission per service. If you remember, we had sort of one radio antenna for radio, one for TV, one for telephony, and if we wanted to have a fax machine, we needed to have a separate copper cable. The most fascinating service they came up with in around 1986 here in Sweden was call forwarding. Ooh. And everyone rushed to buy that service and had to pay quite a lot. And by the way, this company that was the only one that provided the service, they were owned by or part of the government. So it was really easy to come up with legislation. Because you knew who the legislation would hit. Really easy. 20 years ago, we started to get really cool things like number portability. Suddenly, we had more than one company that sold phones, and we could get them in more than one color. And in 1989, the network in Sweden looked like this. And it was, the core network was so small, so we actually, as you can see, we actually could write the names of all the routers over sort of a map over Sweden. We had a 64 kilobits per second satellite link to John von Neumann Supercomputing Center for all over the Nordic countries, and that link was not full. I guess it was before Netflix, right? So another thing was that we had to have both Cisco and microwave access because Cisco routers could only handle IP packets, and we were running a multi-protocol network. In '89, a few months later, Europe looked like this. We had the Nordic University Network that still exists. We had the EUNet, CERN, Switch, GAR in Italy, and that was basically it. And the best thing we had spam and crap in those days as well, but the good thing was that we knew everyone that had an email address. So it was possible, so if you got something that you didn't like, you called them. And in meetings we had, it was approximately like this. It was really cool. So anyways, today we have a different world. And this is why there are so many parties which are confused. Because today global reach is at zero cost. And this of course means that you have cultural clashes and clashes between legislations, and you have law enforcement and others that don't know what to do. So the big issue here is not so much internet, it is globalization together with digitalization. And those two things together creates quite a lot of issues. So more and more things are connected to the internet, and more things are, because of that, sort of computers. But what's more interesting is to remember that each one of us, regardless of whether we're individuals or organizations, we connect things to what we think is the internet. And what is important to remember that whatever we provide and whatever we connect to the internet, regardless of whether it's a service, a fiber, a device, software, whatever it is, whatever we bring to the internet ends up being part of the internet. And we have a collective responsibility to make sure that works and continues to work. So another thing that is happening, so we have shared responsibility to make sure things work. I'm a little bit allergic about all those pictures that say, here's my network, blah, 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 and then we have a connection, and over there is the internet. The internet is all of that. The other thing that is happening is that more and more things turns into services. And the question now is like, what is really, we thought, for example, I think most people in the world thought a car was a car and software was software. And then Volkswagen wrote some interesting software. And the question is then, what is a car and what is software? So more and more things end up being just services. People thought that TV was something that was distributed either over satellite, cable TV network, or terrestrial. But nowadays, of course, the new generation that are about like a fifth of the age of myself and others in this room, they don't really understand like why TV is something special. It's just another service. I am a TV right now, yes. I probably am, or I know I am. So, given that everything turns into services, it is also the case, of course, that with proper internet access, anyone can write the service or anyone can deploy the services. And this is one of those kind of things that, of course, legislators are a little bit confused about. Because it's not only the case that 35 years ago we only had one company or entity in each country that provided television. A little bit later we had multiple of those, but we still knew who they were. Today we have no idea who is providing whatever is called television. And by the way, what is television nowadays? So back to robustness. I will come back and talk a little bit more about this. So whatever we are doing or whatever we are inventing, it is really, really important that the robustness and the resilience and making sure things are stable must start at home. And this is something that is specifically important for providers of internet access and others, which are most of the time the ones that I talk with. And of course, there are also people in uniform and very, very blank shoes that do believe that as soon as there is a problem, in that case, they should come in and help. That is not how it works nowadays. Each one of us provides whatever service we are providing, and we should do it regardless of what the weather is like. So, what is the real difference between the old and the new world? The big thing is that today, you can buy a connection from someone, and then, independent of that, you can get a service from anyone. Part, of course, the fact that nowadays, anything is a service. So it is much, much more complicated that people think that this is what it looks like. I can connect to this washing machine regardless of where I am, but in reality, of course, we know that the connection is actually the ability to communicate with the washing machine is dependent on the functionality of multiple entities' networks. And if one of these fails, communication might not be possible. And even among the people that build internet access and internet services, we're used to a picture like this for the last couple of years, at least, that we have connections from the end device to services. We see more and more east-west communication between various kind of services that we're connecting to each other. We see that, for example, Dropbox is using Amazon cloud storage services and others. And then we have, of course, people that do believe that Internet of Things implies that my fridge will communicate with my light bulbs, that will communicate with my bed or whatever. But the question is whether that really will happen. My personal theory is that just because of interest of cloud services and able to peek into the data what I have in my fridge, there's no market economy interest whatsoever to have my devices at home talk directly with each other. Instead, each one of them will talk to a cloud service, and then it will go east-west inside the cloud only. I'm not looking forward to that. So we have these various different kind of changes that many of us have seen. We've seen hierarchical networks, and then we have I-access and more peering, and then we have more and more content providers. We have division between eyeballs and content providers, and then the question is whether we will have even more interconnects between the providers. Who knows what's happening? And what will the implications be on the routing system? And then, if it is the case that someone that don't know anything about the internet tries to make a phone call and it doesn't work, who do they call? Okay, so given that as a background, let me talk a little bit about what I'm doing. I'm working for NetNode. I'm head of research and development there. We're a small not-for-profit organization owned by a foundation here in Stockholm. We run I-access here in Sweden and Denmark. We have DNS in 55 locations, run Anycast services, and we provide time via NTP. And the reason why we are created is exactly what I just talked about. That we saw in the 80s and the beginning of the 90s, we saw this kind of stress. And together the ISPs here in Sweden said, wait a second, we actually would like to have more and more of these services run by a neutral party. It was run by KTH, like a sibling university or high school, university, blah, blah thing here in Stockholm. But they were not so interested in running commercial services. So in 1996, a foundation was created with NetNode. So you all know about I-access. There were 3 ISPs from the beginning in Sweden, and it was actually 21 years ago. Almost 25 years ago. It was in March 1991 we had the first commercial ISP in Sweden. And this is basically what it still looks like. And it looks like there's an all ISPs in Sweden and also most ISPs in the world. What's a little bit special with the IX that we have here in Stockholm is that the one in Stockholm have 2 switches in 2 locations, and there are no interconnect between them. Instead, all ISPs get 2 fiber connections, 1 to each one of the switches. And then it's up to the ISPs to make sure to use them as redundant as possible. And I will show a little bit how well and how bad that can work. So another cool thing is that when deregulation started in Sweden, the regulator understood that it's actually pretty important that they provide good location for telcos or for the ones providing telecommunication services, because each one of them will not have enough funding to be able to actually make the investment needed. So they built these bunkers in Sweden where we are located, and also many of the telcos, but not everyone that is a customer of ours. They look like this. How far below the ground we are? The answer is enough. And of course they are made according to the standards of the Cold War, and as you see on this picture, the actual building where the buildings where the actual equipment is not connected, is completely isolated from the rock, and it's EMP safe and whatever. So it's actually pretty cool. The difference between these and other old military installations here in Scandinavia is that military installations are normally made for soldiers to be there, which means that you have about 150 watts per square meter or something. These things are made for telecommunications, so we talk about 10 kilowatts per rack space. So, and they're pretty big buildings. They're sort of 2 or 3 story buildings, like 150, 200 meters long. So it's pretty big. It's fun. So one of the reasons why I left Cisco and joined NetNode, even though I've been following NetNode, was actually to be able to work with cool stuff, which we are. So this is the traffic last week. You see we are peaking about 1.2 terabits per second, which is not the largest IX in the world, but we are pretty big. If you look at the last 2 years, it's always increasing in August. For some reason, it's increasing, as you can see, a little bit later this year. The increase starting in September instead of August. I claim it is because we had such a good weather here in Sweden. So it ends up being delayed with about a month.
I think they wanted to see the EuroBSDCon page, and they were in the press brief.
There are lots of reload on the various web pages. And then the DNS hosting we are running. You will see kind of interesting DNS things that we will release this fall. Hopefully you might be interested in that I've been working with for 3 months. So, next phase of this presentation. I will go through a couple of things which I find are very, very important issues at the moment for deployment and operation. And remember now that it was probably, like Paul Wicks and myself had this discussion a couple of weeks ago when we both recognized that we have not really written code for some time. We have other people writing code. And I enjoy the blog post that you posted, if it was this today or yesterday. And I found like, wait a second, yes, I do write code, but it's probably so ugly, so it should not be in production. So today I'm more operation more than code development. So this is based on my experience as from operation more than development. First issue, moving packets. Is it hard to move packets? It was quite easy when it was only your own packets. And then the second phase of the internet, I claim, was still a little bit hard, but you could still explain why things didn't work because it was still IT companies that it was their packets. But nowadays, if the packets are not moving on the network, you have sort of anyone's business case will suddenly stop. So, since here in Sweden at least, since around 2010, suddenly most business cases and business processes relies on a functioning internet, that packets move. And this implies that there is a different responsibility for the ones moving packets to ensure that they actually move. If you remember, a lot of people say that, oh, the dot-com boom and everything, just the bubble just collapsed, poof, boom, it was here, okay? I have another theory, specifically here in the Scandinavian countries, this crash, which was on the stock market, did not decrease investment on ICT services. It actually made it cheaper. And the main reason for that was that the ones that lost the money were the ones, the banks and others, that invested in big cable systems and fibers that actually, and they went bankrupt. So they had to sort of directly write off all of that fiber investment as a loss. And that meant that whoever bought those fibers really, really dirt cheap didn't have to charge high fees to recuperate the investment. So suddenly the price for dark fiber actually went down, which made it really easy to build working internet in the 20th century. So today, I saw a blog article from Cisco. They have released a new version of the Virtual Networking Index. And they point out in this that in 1984, is an interesting year to compare with, but it's kind of fun, as you will see. It was a total of 14 gigabytes of data that moved over the internet each month. In 2014, each user of the internet moved 14 gigabytes of data each month. Let that sink a little bit. In 1980, today, the total amount of data moved over the internet in 1984 moved over the internet in 2014 once every hundredths of a second. Okay, 1984 is a little bit sort of weird. We cannot compare with 1994. In August 1984, I got my first IP address. So that's sort of quite early. If we look at just 2000 to 2014, we had an increase of more than 500 times. This is not slowing down. In 2011 at Cisco, I made this slide and presented this. 2011. And I said that in 2013 we will start to see quite a lot of video content, and in 2025 we will start to see video communication. And people said, oh boy, you're crazy. The internet cannot be used for video in only 2 years. And video communication, go home. The internet will not work for that. Like all of us that have been around, we know that we have heard that a couple of times before, and so far the internet has not broken. So what we see now is that I was actually conservative. Well, in 2011, people thought I was crazy. Because this is what the real picture looks like that we have seen too many times. You have time, this is where we are. That is whatever on the y-axis, and 6 to 9, so from 6 months to 5 years, we reach a limit where the internet will not work anymore. I've been doing this picture since 1989, and I still get this. At the moment, we can neither distribute TV nor distribute radio over the internet. That's what I'm told, so it must be true. In 6 months, we will not be able to listen to radio over the internet anymore. So what is the problem with moving packets? It is not so problematic to move packets. What is problematic, of course, is to build a network that can withstand any kind of stress. And to be honest, that is completely silly. The important thing is to not be surprised. So if you have built a network, you should know what design you have chosen, and you should know what will break. If you know what will break when your network comes under stress, then you can also know what will you do when it breaks, and what kind of parameters do you watch, so you get an early indication. Where will you start to get packet drop? If it is the case that you only have a partially working network, for example, if you have redundant links and one go down, can whatever is left carry all the traffic? If you only know these kind of things beforehand, you're in a much better situation than if you are surprised. And then, of course, if you have all of that traffic that you think is unwanted, can we minimize the amount of unwanted traffic? And the big question there, of course, what is unwanted traffic? And of course, that is also something people disagree about. If it is the case that we're a packet-based network, it doesn't linearly fall apart. It looks like this, that if we increase the amount of stress on the network, we have functionality on the y-axis, it goes pretty well up until a certain point where it falls apart. And there are two different questions that when we build a network that we should not mix. The first one is, how can we move this point when the network collapses as far to the right as possible? And there's a completely different question on how do we communicate when we don't have any network anymore. Too many people think that they should work on this question over here. Some people should work on this, but very, very few. The rest of us should concentrate on moving this point Z as far to the right as possible. I showed this slide to the Swedish military, the people working with cyber defense in Sweden. And in one of those presentations, a big room like this, there were 3 people up in this corner. It was like, hello, yes, what do you want? That is correct, they told me. So what do you mean? We are a couple of people working on this on the right-hand side over here. Okay, good, checked. So, done. They are the ones that make sure that Swedish Prime Minister can actually communicate with the head of the military when things are really bad and there's no electricity and the rest of us are looking for water. Or beer or whatever. But the problem is that you have, I don't know how many organizations we have in Sweden, including people in nice clothes and blank shoes, that think they're working on this. Concentrate on this to the left. Excuse me? Oh yes, this is very, very sexy. You really would like to be able to communicate when there is no power and you're hungry and you really want to sleep. But when we are in that situation, there is not much we can do, right? So, for those of you that actually would like to understand more of why it happens like this, it's a normal MM1 queue, combination of Poisson exponential distribution, packet-based queuing, and many of you have probably done event-based simulation and stuff. And I need to show this because this is actually what I actually have done. before I started with computers. The reason why I started with the internet was actually that I was doing math and graph theory, but the software we used for simulation was so crappy, so I started to work on that instead. So that's the background. So today, I'm instead working with these kind of things. Okay, so this is actually what it looks like, and many of us know this. So, once again, build a network that you think you know how it works. You think you know how it will react if it is the case that it ends up under stress. When something is happening, try to gather information about it, analyze it, recommend improvements, implement improvements, update your knowledge about your network, and then just wait until something happens again. And then coordinate and cooperate with whoever you need to work with to be able to maximize the functionality without paying an arm and leg and trying to get a network that works all the time, and then you're surprised when something goes bad. I was running around at home looking at what kind of things today, even though I'm a geek, I've not really been gathering, sort of collecting things, talking with the internet, but there are a couple of things. A camera in my chicken coop. This is what it looks like. No chickens at that point in time, I guess they're out eating. Phones, of course. Video conferencing to the office in Stockholm. The alarm system. Oh, wait a second. Does this need? Yes, it does. Temperature sensors, not so important, except one sensor in my freezer where I have all my meat. Okay, so if that goes poof and I don't have internet access, I will not get the alarm that my food is going bad. The infrastructure itself can go bad at home, of course. And to my home, I only have a radio link, no copper, no fiber yet, which means that a radio jammer could also sort of kill the connection to my home. Not good. This is what it looks like where I live, by the way. This is from the mouse towards my home. And we see that even in Stockholm, you see that people succeed so well here. So this is the flight timetables. Didn't work so well. Some problem there. Another one. I collect these things. I think this is fun. There's another one. Press the button or something. I don't really know where the button is. And this is an interesting thing. Coming back to time. So I was between 2003 and 2014. I was an advisor to 3 different IT ministers in Sweden. So I was talking directly to the minister for 13 years, and this picture I taken in the meeting room in Rosenbad, which is the office of the Prime Minister of Sweden. So this is the room the Prime Minister of Sweden is receiving his peers. You don't have to know much about time to understand that there's something wrong in this picture, okay? Okay, more things that can go bad. This is actually me not knowing programs. This is one of the few things that I actually built that actually is live. I live in an old water mill from 1680. And if you live in a water mill, you do understand, and you don't have to know so much physics to understand that by definition, the floor level of my basement is below the water level of the creek. Okay, water wants to come into my basement all the time. So this is an Arduino with some sensors. It starts pumps and makes sure that I don't get a flooding, because that would be bad for my wine and my heating and other kind of things. You see, there's a spider up there as well that guards the whole thing, by the way. It also has a web server like this, and the reason why I implemented a web server on the Arduino is just because I could have something that pulls the web server and uses a Philips Hue system and turns on lamps in the living room when things go bad, so my wife can call me before the basement is flooded. Okay. What if there is no power? Okay. One thing that we learned in Sweden in 2005 is that telecommunication is dependent on electricity. yeah, a lot of people are like, oh my, this is something new. But for a society, it's actually pretty complicated. Because just like in many other countries, we don't have national roaming. If the electricity went down, we don't have any cell phone network. And the question then is, how do you restore the electricity network when you don't have any mobile telephony? How do you synchronize and coordinate the work? Well, to start with, many of the cell phone towers actually have diesel generators in Sweden. So the only thing that was needed then to get diesel to them. That was a little bit problematic when there were trees all over the place, including over the roads. And by the way, the area that had trees all over them because of the storm, like this picture, is the size of Netherlands. So if you think about the size of Netherlands and a big forest size of Netherlands, that was just all trees down. So the most important people the primary people to give national roaming on their SIM cards were the drivers of the diesel. Not the mayors, not the doctors, not the whoever. So they could coordinate what they did. In this storm, only 7 people died, which is kind of interesting. It's quite a low number. All of them died by electrocution when they restored the electricity. And the reason for this is because there were hundreds and hundreds of people that were brought in from other countries that simply didn't really know the logistics and how the Swedish power network works and how to sort of properly ground lines before they start working on it. And they still didn't have any cell phones, so they could not communicate back and see with electricity. They made a mistake, and when you work with a couple of 100 kilovolt lines, you don't really want to make mistakes. So 7 people, unfortunately, lost their lives. After that, in Sweden, we do have exercises in cooperation between the electricity and the telecommunication providers, and we actually do have exercises approximately every month. This is an example of one electricity provider that during a storm lost power in this area. You see the red southern part of Sweden, Stockholm up there, no power. And nowadays you can get these maps over the interwebs, and you can also, when looking at the same time at a provider of cell phone telephony, it looks like this. So as you can see, it's pretty good. There are quite a lot of the network that are still up and running. But at the same time, there are large areas of outages in areas where there is not much redundancy regarding electricity. This is, once again, from the government's offices. It's actually a system that is really, really good, because if you have large buildings and stuff and you need to pass around physical stuff, you use these kind of pneumatic systems. They also need electricity, a reminder. No one can So, build a robust network, but calculate really carefully on where you make the investments so you don't make the wrong investments. Prepare for mistakes and errors. It's still the case that fiber breaks and physical errors is the most common in Sweden by far. Electricity outages and that people cut off by digging fiber, that's the main reason for outages. And of course, surprisingly high amount of traffic. We have these kind of articles in Sweden now again, and now Anonymous is attacking us again. From an ISP's perspective, or us at the Internet Connect point, it looked like this. We saw nothing. Of course, there were some websites that died, but one of the issues we have is this, that is in 2012, you have 400 gigs of traffic. 2013, we have 700 gig. And today, we have 1.2 terabit. This is an increase that we need to design for. So just normal increase of traffic is something that you cannot really, you have to think about what investment cycles you have. Other example, you see, it might be a little bit hard to see, but there's a noticeable peak here to the right. This is the exchange point in Stockholm. And this peak here was when this guy was jumping from a balloon and everyone wanted to watch it live. That was noticeable. Here's another example, one of our customers. That is noticeable. And you also see the next day, the Thursday, is also quite high and a little bit lower on the Friday. This was Apple releasing iOS 8. So what is surprising amount of traffic can very well be sort of okay traffic. But you also can have this kind of problem. Here's one of our customers, which, as I said, 2 fibers, one of them broke. Poof. Clear, it's pretty easy to see where the break is. If we now look at the other connection, you see here, it's pretty easy to see that here's where the break has started. But you also see that they had then 2 10-gig connections, that they could handle all traffic over one fiber except during about 3 hours. And here the question is, was this something that they calculated with? Was this a surprise? If you were them, would you upgrade or not? And remember now that it's not a clear answer here. Should you really invest to have 0 packet drop, or was it okay to be able to handle 50% of the time? They were a little bit unlucky that the fiber break was actually during peak hours. Maybe that is a risk to take. The important thing is that I hope that they knew the answer before it happened. So, the longest time I spent on this, build a redundant, robust network in a way so that you are not surprised when something happens. Next thing. How many times have I told people to start to use IPv6? So many times so people say, go away. And that's what they started to tell me in 1999. Go away, IPv6. Anyways, the big problem here, of course, is that we literally don't have any IPv4 addresses anymore. Here in Sweden, you have 3 different ways of getting IPv4 addresses. You can create an LIR, pay 3,000 euros a year, and you get a /22. If you want another /22, create another LIR, you just have to pay. The second thing you can do is to buy a company that have IPv4 addresses, and don't forget to include them in the inventory so you get them. We had, I was working with one company that actually bought another one, and they forgot the IP addresses. That first of all means that they made a mistake in the valuation, and secondly, they had to go out on the market to buy IP addresses that they had to use for the services they bought from the other companies. So in reality, they lost twice for each IP address. Or you can just go out on the market and buy IP addresses. They cost today approximately $10 US per address. The price goes up and down quite a lot. It has gone down the last week or something, but say around $10. It's not 1, it's not 100. And all of this, of course, we all know the IP addresses go away, blah, blah, blah. But nothing is happening. Everyone is waiting for everyone else. This is what we talked about. RFC 1918 gives us security. Yeah, right. The big problem which scares me is that we have been here. That even though everyone knows that we run our IPv4 addresses, you can still get some. We are now moving into this phase where actually everyone can buy an IPv4 address. But what we do see, and what we have seen the last couple of months, and we in SAC has actually brought up and started to work on this issue now. At last, Paul, at last. Paul was a member of SAC, and he was arguing in favor of us starting to look at this problem, and now at last we are starting work on this. We see an increased number of people and organizations that look at what IP address space is allocated to someone but not announced yet. And then people start announcing that. So people are today, if there are IPv4 address space that are, even though it's allocated, if it's not in use, it will be in use by someone. Just because we moved into phase 2 so quickly, I'm really nervous over the third phase. Because if you really run out of IP addresses and you cannot pay, I don't think you care if it is the case that you use IP addresses that is allocated and announced by someone else. If enough people trust you, you can still run your traffic. There are some third parties somewhere else that was actually using the IP addresses that will not be able to send any packets anymore. And I'm a little bit nervous that we will move into phase 3, what I call phase 3, pretty quickly. Yeah, there's a comment here that it already happens. Yes, it already happens. It doesn't look good.
I was very scared when I saw a range which I tracked back to the Department of Defense on our very secure servers in a high secure zone. To find out that the company uses them for storage.
Yep. So there's a comment here, and just like stories. And what really scares me, it's not that this happens, but we're sitting here, of course, a room with pretty special people, but still, immediately, we hear someone that has an experience of this. Hands-on experience. This is really scary. Well, we have 11/8, and we have the UK government selling out IP addresses, but the amount of growth we have at the moment, it just buys us a little bit of time. A few months, it doesn't matter if it's a few months or a few years. It's still a very finite resource. So please start to use IPv6. Next. Domain names, certificates. We had a look at this in ESAC. And we saw that, well, the domain names that people actually query for to the root zone, through the root servers, are not only the TLDs that are allocated in the root zone, people query for other things as well. I looked at what we had at iRoot during 24 hours, and we had, and the first thing I asked a guy, just because I don't write software myself, I asked a person to please have a look at what TLDs we get queries for. And he wrote a script, and he didn't come for coffee. And it's like, what's wrong? My script is running out of memory, and I run it in Perl and Python. I just don't understand what's happening. And then when he had a look at things, he just allocated an associative array because he knew that there were like, whatever, 250 TLDs. The problem is that we had queries for 162 million unique TLDs during 24 hours. So the size of his associative array ended up being a little bit larger than he expected. Which of course I could have told him, but I just forgot about it. So I actually had to buy him dinner. But anyways, but if you look at the common ones, there's an extremely long tail. So is it possible to sort of see what actually happens there? The big problem has to do with the domain names that are supposed to be used only internally in enterprises that does not end in a TLD, like www.corp, accounting, and this is of course just because people can use search path in the result.conf configuration. They cannot be used in the internet. There's no place to send the validation email until you have a TLD created with that name. So of course we have, I'm very, very lucky to have very creative people as members of ESAC, and one of them had this presentation where he created a certificate request for www.site with his email address. And by the way, I have replaced his email address with mine, but it's absolutely not mine finding. I'm just, yeah, I want to sort of, I'm allowed to show the slides by sort of hiding it, so. Anyways, and then you go to a CA and say, I would like to get a certificate for www.site, and there's a warning here which is hard to read, but it says, this requested certificate is for a domain name that is not in use of the internet. Are you sure you want it? Yes. Click. So you get the certificate. www.site, everything is fine. Then you set up a fake root, you delegate .site to yourself, you set up a web server, you serve the cert, and boom. Of course, the web browser says, oh great, I have a cert that I can verify with the CA. There's no indication in the cert that it was allocated for something that was not a domain name. And of course it works in other browsers as well. So this scared us in SAC so much so that we formed a work party, we looked at the EFF SSL observatory data, and we see that at least 157 CAs have issued these kind of certificates. We talked to the CA Browsers Forum, and they said, yes, we know about this. What? What did you just say? Well, you know, after a new TLD is allocated by ICANN, 3 years after that date, we will stop issuing certificates for that TLD. 3 years? I know that Paul has a project that looks at what kind of damage is created by domain names within the first 3 hours they are allocated. And here they're talking about 3 years. I only have 2 words for that. Insane. So the conclusion from us, ICANN must do something. So we had a disclosure policy, and nowadays, if you see something delegated to 127.053.53, that's part of the sort of collision detection mechanism. But of course, not all CAs are members of the CA Browser Forum, so choose certificates carefully, do not use search path, do not rely on it, and start to implement and deploy DANE. I cannot emphasize that. DANE, please. Hardware. This is fun. Heartbleed, you know about that. This is something I worked with Cisco, trying to convince customers not to buy hardware on eBay, buy it from Cisco. And then, yes, I knew our prices, yada, 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 yada. But anyways, it must be sort of interesting. So this is what happens. We saw in the mid-80s an increased number of break-ins into DHL freight containers. And what people did was to replace the switch cards to the switch card that did a little bit more than what it was supposed to do. They put the new switch card into the router and sealed the box, and it was shipped to the customer. It's not so easy to see the difference. Here's one example. Okay, if you have the 2 cards beside each other, you see that there's a difference, but honestly, it's not really possible to see which one is fake, to know which one is fake. You have the Lenovo issues, where everyone can sort of decide themselves what to think about that. And then I just got, this was literally just before, when I was sitting in the corridor out here, I got this picture from a friend of mine in China that I work with regarding freedom of expression, a journalist in China. This is the wall outlet in his office that he opened. It clearly includes more things than just what delivers power to the outlet. And this is not something special for China. These are kind of things that happens all over the world. Not fun. Then we, of course, have good things that happens as well. We have the Cryptech project that many of you might have heard about. Exactly. They are developing open source hardware and a specifically open source random number generator. Please participate if you're interested. So, be careful with what you install. Last thing, time. I must talk about this because this is the coolest project I'm doing that I can talk about. So you saw this picture. Time is in reality 2 things. This is actually really easy. Something that ticks, tick, 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 and then you have a counter. This is not hard. Put them 2 together and you have a clock. The problem is, yes. The problem, of course, is what if you have, if we only had 1 clock, that would be good. But if we have more than 1 clock, then suddenly you might have some issues. So we have precision and accuracy, and of course, at the end of the day, we want precision and accuracy. Excuse me?
How fast are you subject to time dilation?
Yeah, how fast I am? Yes, well, at the moment, yes, I'm another 8 minutes, and then the presentation must be over. Anyways, so this is the automatic answering machine for time that we had in Sweden. It is a magnetic thing that rotates, you call a number, these heads move, blah, 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 and okay. This is not such a good precision on this one. But the big problem, of course, is there are different time scales, and you know all about these kind of things. We have leap seconds that create this headache for us. It's currently discussed in ITU-R regarding we should continue to have leap seconds. How many people are involved in the leap second discussions? Is there anyone? Okay, one. Okay. Okay, yeah, of course. We'll see what happens. Yes. So the question is what will happen here with UTC, but in reality, we have the big issue with how accurate and with what precision do we need time. My example that makes most people understand has to do with going to a bar. Okay. To be able to meet someone at the bar, you need, first of all, the geographical location, but then you also need to agree on when to meet at the bar. Then I've done some empirical studies for many, many years, and I think that when you go to a bar, you need to have clocks that go not more than 17 minutes difference, because it takes me about 17 minutes to drink a beer. Because if I arrive to the bar, I order a beer, I wait for my friend. If the beer is gone, then I leave if the friend has not arrived. And that's about 17 minutes. But if we do other things, for example, if we have timestamps on some kind of sort of stock market issues, it's really, really important that the precision and accuracy of the timestamps is such that we can still know in what order the events took place. And this starts to become a little bit complicated. And then if people say, wait a second, this is something new just because of the stock market, I can point out that one of the oldest laws we still have in Sweden from 1736 says, and this is in Swedish, but let me try to translate, if it is the case that someone sells the same goods twice, the first buyer keeps the goods and the seller has to pay a penalty. So already in 1736, we need to know in what order economical transactions took place. And then you have the EuroBSDCon and all of those kind of things. There are multiple other kind of things, for example, procurement processes, faxes to RFPs that have been rejected, data from surveillance cameras that have not been able to be used. For example, the murder of the Swedish foreign minister. It delayed the police investigation 3 days because the timestamp of the video cameras were not accurate enough. So they didn't really know how the criminal moved around in the shopping center. And then, of course, when you have road fees like here in Stockholm, that changes the fee depending on what time of day it is. Cool. There are actually people that have complained on the road fee and challenged them that their clock was wrong. They immediately improved their time system and they gave the money back. So today we are running a rubidium clock and we have about 10 to the power minus 6 seconds, but this is something we're now making much, much better. The regulator together with us at NetNode, and we have this is the first system up and running. And of course, once again, I'm nowadays a manager. I pay for these things. I approximately know what they are. I don't know what they do. But anyway, so nowadays we are asked by the regulator to provide NTP 1588 time and frequency services for free for anyone that would like to access them. So you will see more of this fall. And for interested people in Sweden, you can contact me because on October 27 we have a geek meet related to time and 1588. Whoops. I wanted to show the last picture. There. For those interested in time issues, 3 cool readings. The last one in Swedish, but anyways. With that, thank you very much.
I would like to hand you a gift. I know you might have tried this on before, these spirits, but accept this gift from us. And it was a very nice speech. Thank you very much.
Thank you.
before the EuroBSD board starts its point, we would like to welcome one of the frequent EuroBSD visitors from afar. He's from Australia, and that means that he might have an upside-down perspective on things. Cheap shot, sorry for that. But he would like to say a thing or two before we start, so I'm handing over the microphone to Rod Whitworth.
Okay, everybody. I have enjoyed being a part of EuroBSD, even though it's got nothing to do with my country, but it has been a wonderful thing to experience. Usually, if I just disappeared, nobody here would think about it too much because people give up being there. In this case, I want to explain why you'll, excuse me, why you'll probably never see me again. I've got an autoimmune disease attacking my eyes. They will go blind. Not only that, but making it harder, is that I'm beginning to suffer dementia. It's not a good combination. But I don't want to bring you all down. This is just why I'm here. I've got some little toys for various people. Excuse the first one because it wasn't really to be a part of the deal, but we'll talk about that later. So I'll take the padding out. And while I'm doing that, I'll give you some idea about what some of those things play up with. We can just dump that there for a while. Thank you. Now, I've been a collector of tech manuals and that sort of thing, and I think it'd be a pity if I shuffled off and some, excuse me, and some relics were destroyed because I wasn't there. So I'm going to hand some out here. How about it? Come down. No. Kirk. He's my junior, you know, this bloke. By several years. And I don't know if you ever had a copy of this, but a few of the guys at CSRG did.
Fire in the Valley. No, I do not have this. Thank you.
There is a photograph in there. Well, you can wait to see it. But there's a photograph in there from the homebrew, and I've forgotten who was. I think it's one of the first sets of stuff. But anyway, I was visiting there, and this blurry creature right up the back, because he came in late, was me. So there you go. Do you want to see the old Cisco stuff? Definitions?
Internet working terms and acronyms from Cisco systems.
And that goes way back a fair bit.
Ah, a term describing the passage of a data packet between two Cisco network nodes.
Now, this gentleman has done a pretty good job for you guys.
Really? Awesome.
And I got a couple of books for you. They are early copies of Unix.
Volume 1, Unix Programmer Manual.
And 2.
And Volume 2.
And the Bell Systems Technical Journal Special Release.
From 1978. So now you cannot only expect strange conferences, but also strange programs.
I'm going to ask a favour. Maybe somebody fits this thing. We were supposed to have a guy who is a part of the BSD, Open BSD team, who helped me out a lot, and he lives in England. Do we have any Angles in here? Can you deliver that?
I'd be happy to. Whereabouts in England?
He's down the southwest coast, I think. Okay.
Was it Stuart?
Stu.
Stuart.
Yeah. Where's?
Exeter is where his father lives, but he himself is at London, I think.
It's even better. I'm based out of London.
Let Stu travel it, because it's silly for me to take it home and then pay squillions of dollars for it. So let me get rid of this around the place. Oh, and this padding, where is the snow bunny that can use this? Because I certainly can't. I suggest that somebody might organise to raffle this or something and put the money towards the foundation. Okay? I can't use this. Now, I think that's just about checked most of it, except that I should tell you something of hope about my problems health-wise. And that is that you should know the 3 benefits of Alzheimer's disease. Number 1, you get to meet new and interesting people every day. Number 2, no. You only have to have 2 videotapes. And number 3 is you get to meet new and interesting people every day.
Thank you very much for that, Rod. Let's see if I can produce a neat picture here. I'll start off. I have a few thanks that are in order. Let's see first. Okay, something like this. Yeah. So, as the arranger of this conference, after all this time, I have a bunch of thanks. I would like to give thanks and give you the chance to give a round of applause to all the local organizers. So I want everybody of, wait. Let's come down, all our local helpers with the orange bands. And you two also, right at the time. Get in front of here. No, come. Yes? These are the people that actually have made this whole thing run. And if you don't know how that works, it looks like this. I would also like to take the opportunity to thank the program committee. They don't have to go down. They have had to turn down quite a bunch of good talks, so they might want to keep hidden. They look like something like this. But they have been a nice bunch to work with anyway, and they've been doing a good job of introducing the people, the speakers to all of you. So I'm very happy for the program committee. So please give them a round of applause. Another group that also deserves a thanks is the EuroBSDCon Foundation. They will show themselves later, but they usually work from the shadows. Big thanks to them. And of course, this would not be possible without our sponsors. So another round of applause for all the great sponsors we have here. Lastly, before leaving the word over to the rest of the foundation, I want to say a few things about arranging the conference. He's not here right now, but one of the former EuroBSD conference arrangers said that you have been really good at herding cats, and I thought that herding cats should be easy because I have cats at home. So I should practice, and this one doesn't let me herd him anyway. But I thought, okay, that's not fair, because that's just at one random moment in time. So I took another picture, but it looks like that instead. So that's the amount of herding I have been managed to do. But it turned out to be quite a good conference anyway. So I hope you all had a really good time.
See if the dongles work. Yes. Trouble. Oh, do you have a to convert this or?
Right. No. Oh, you don't have.
No. That's why I sent it to you.
I might have it in my bag. Är någon DisplayPort-adapter eller något?
Jag tror att det ligger en utrustning.
Jag har tagit en. See if this one works. It's not the official white Mac core, but it might turn into VJ.
Might work. Maybe it works, maybe it doesn't. Otherwise, we'll just have to keep all this a secret from you. I just need to plug into something.
Awesome slide.
Awesome. Yeah, that seems pretty good. That's a proof screen. That actually working. Good, yeah. Excellent. So if I press this button, maybe things happen. Okay, excellent. Can everyone hear me? I don't do any...
You can do it.
I can just use this fancy device. Then I don't have to shout at you. Which way? That way. Oops. The other way? The other way. All right, so Jana, thank you for organizing this edition. Every year we have this EuroBSDCon for a while, and I want to tell a little story about how this happened. But before we go into that, for how many of you here is this the first time you turn up at a EuroBSDCon? Well, that's good, because Kirk was explaining earlier that in order to be sustainable, you need, what was it, 20% new faces every year? That was more than 20% of the room, I think. So, not that the room is full or anything, but that's good news. That means we're sustainable. Another more interesting question is, how many of you have been to every EuroBSDCon? Every EuroBSDCon? Nobody? Yeah, I don't think there's anyone left. So I've only missed 2, and that's, yeah. You've missed 1? Okay, so you're better than me. You missed 2. So many people have missed 2.
One person's missed one, that's not too bad. But every EuroBSDCon, we've had a couple. And this is an interesting sort of thing to look at. So EuroBSDCon moves around a little bit, but Asia is a fairly big place, right? BSDCon, I'm sure Dan is around here somewhere. It moves around a lot. Well, it moves around a bit every year too, between buildings. The Earth moves. EuroBSDCon, on the other hand, Europeans, we like to move around a bit. So every year we migrate and we try not to visit the same country twice. Sometimes we've had a bit of overlap and we've had one gap here, but we move from country to country every year. And this presents some unique and interesting challenges, especially also since we have people coming from everywhere, so we need to actually get these people there. So it would be easy if we were to organize, a Sweden BSDCon, and we would turn up with our BSDs and the Swedes would come to us, or we'd organize a German BSDCon and the Germans would come to us. But it doesn't really work that way. So this year we had 244 participants from 26 countries, and the top 8 countries is a pretty diverse group, and then the final 20% is still from 18 other countries. So lots of people just find their way into here, and it's harder than it looks. So every single country we go to has unique new challenges. We need to somehow find a building that fits this crowd of geeks and that wants us to fit in their building. We can't just go and squat a building. Universities, they have views. Hotel people, they feel that you need to give them money. And by moving from country to country, we need to bootstrap a new team every year. So if you organize Sweden BSDCon every year, or Slackathon, you can slack off and, build it and they will come. And next year, okay, copy and paste the conference from last year. Or as I've been doing with FOSDEM for the past 15 years, just copy and paste the conference and, increase it in size twice every year. EuroBSDCon, let's find a new country, and then, organizing a conference, we need to find some people. So that's a bit difficult. And every year, for the first couple of editions, we were just throwing away the experience of organizing a conference. So what we're also doing is we're finding that some conferences run a profit and other conferences run a loss. Happily, the last thing doesn't really happen much, but organizing conferences is eye-wateringly expensive, regardless of where you do it, because you need to get speakers from all over the world into your country, whichever one it may be. I'm keeping this a surprise, the suspense must be mounting. It's also difficult to take money from people on the internet legally. There's two curves there, right? So taking money from people on the internet illegally becomes progressively easier, as Patrick told us earlier, but taking it from people legally is more and more difficult. So if you're, a bona fide organization organizing conferences in different countries every year, and you're registered in one country and taking money in another country and then using it to pay for things in a third country, banks look at you really strangely. So also sponsors find it difficult to aim money at some country somewhere in Europe and hope it arrives in the same shape and size. So these things are difficult. So we set up a foundation, a persistent entity, to take some of these challenges. And the history of this entity is a bit interesting too. So in 2001, we had a couple of people in England on the small island off the coast of Europe saying, we should do a conference. Because, all these BSD conferences, they're always in North America. They're far away and, it's nice here. So we should do a conference. And then in 2002 in the Netherlands, this conference thing, that was fun. Should we do another one? Okay, yeah, we'll do another conference. So the people from the first EuroBSDCon were not involved in the second one. And, it just happened because people stood up and did it. And then 2003, was Paris, and didn't happen because, well, Paris. France, right? So in in 2004, the Germans, France didn't happen. So the Germans, hey, there wasn't a conference last year. What happened? Yeah, well, France. So let's work. Let's start this up again. And we had EuroBSDCon in Karlsruhe, and then at dinner, a couple of criminals sat down and thought, wouldn't it be nice to have a foundation that organized this, and from year to year. But of course, these criminals are BSD developers who are well known for their procrastination skills. So between 2005 and 2010, conferences just happened according to the previous theme. But not France. Well, we had one in France, which nearly, no, never mind. So conferences happened somehow, but the noises around the foundation just, kept getting louder and louder and louder. And then in 2011, the Dutch people organized Marsen, and they, instead of organizing its, setting up a one-shot foundation or a one-shot company or someone taking the risk all by himself, set up a persistent foundation to organize EuroBSDcons in the future. That was 2011, so this is the fifth one we're organizing, or the fourth one, I've lost count, organized by this foundation. So for the past couple of years, our sponsors have been throwing money at the foundation, and all the bills have been paid for by the foundation, speakers have been paid for by the foundation, and we've been taking your registration fees from a persistent entity. So what does this foundation thing do? We take ownership of all this technical infrastructure. We lost the EuroBSDCon.org domain at one point. That was a bit embarrassing. So we've got that back now, and we keep it. We lost the old websites many times because people move machines and, oh yeah, we organized that conference 10 years ago. Yeah, we probably don't need the registration website anymore. But then, that's a bit of a pity. So we found all of those back, and we put them on our machine. Also, as I said, we were throwing away all this experience organizing conferences. Now we have this foundation with a bunch of people who've been doing this for a few years, so we do that. Also, we want to make sure that EuroBSDCon conferences remain family gatherings where we have all the BSDs, not just FreeBSD developers, not just OpenBSD developers. We want to ensure that it's something for everybody. And, practical things, we want to keep it easy for people to throw money at us and for us to pay for these events wherever they might take place. So that's what this foundation thing does. And how does it work? Well, since the Dutch people were doing it, we have a non-profit foundation registered in the Netherlands, and it's fine there. The Netherlands, it's a small country the size of a forest in Sweden, and it's mostly underwater, but they seem to have this under control, and it's fine there. So we're happy being a Dutch foundation. We wrote our bylaws carefully, so we require representatives on our board of directors who are members of each major BSD, and we left the definition of major BSD purposely vague, so if another BSD feels that they are major, they should come and talk to us and join the board. We've also got hats, because you have to have hats when you're a foundation, and the hats cannot represent their BSD project, so when I am on the EuroBSDCon board, I have nothing to do with the FreeBSD project. When Henning is on the EuroBSDCon board, he's not allowed to mention OpenBSD ever. Except, he is wearing the OpenBSD hat, so he must, anyway. And then to provide continuity between EuroBSDCon events, we have the local organizer from this conference and the last conference and the next conference join the board and rotate in and out. So if you volunteer to organize EuroBSDCon, you're committing for 2 years, possibly 3 years, not for just 1 year. More on that later. So a bit more about these donkeys, which Jana has there. So these BSD representatives, we thought we should come out of the shadows and maybe introduce ourselves. We are not just taking your money and giving you a conference. We have faces. We like to hide them. So BSD representatives, we have Beat representing FreeBSD. We have Henning representing OpenBSD. We have Petra, who is disappearing somewhere. oh, she's gone off to the airport, representing NetBSD. If you think you are a major representative of a major BSD project and want to join us, maybe come and talk to us. Our local organizers, Shriana organized Sofia last year, so she's she can be released this year. She can leave the board and finally take a holiday. Janne organized this year, and he thought he was free, but now he gets to organize next year, wherever that may be, together with this mystery person, whoever that may be, organizing EuroBSDCon next year. And then we have some hats. For some reason, I seem to be treasurer, so I am taking your money. By the way, I'm going for a 3-month holiday now, and we have no profit. We ran a loss again, and I really can't tell how this happened. We have a secretary, Adrian, and our chairman position is unfortunately vacant, and Henning will talk about that a bit now. Speaking about our chairman, so Henning, I will hand this to you.
Get it stuck in your ponytail.
Yeah, sure. So this is actually the first EuroBSDCon where we do not have Paul Schenkerveld. He was the only person who made it to everyone, and he got increasingly involved in organizing them. Paul's been the father of the EuroBSDCon Foundation. He set it up, and he got most of us aboard. Paul really lived the conferences, lived for the conferences, was not limited to EuroBSDCon. He went to increasingly often to the BSD cans and AsiaBSDCon. And unfortunately, earlier this year, just a couple of days after returning from AsiaBSDCon, he passed away. The social aspect of this conference, is bringing all the people together, was very, very important to him. And in his memory, it's my pleasure to announce the Paul Schenkerveld Travel Grant. There are plenty of people who should attend a EuroBSDCon and, bring faces to names, but can't afford it. So, in his memory, we decided to set this up. If you know such a person, please let him or her know, and please spread the word. Please make them mail us and apply for the travel grant. The 2016 conference will be the first one where we bring one person in. The process is that the EuroBSDCon Foundation Board decides who deserves it most and, gives them the travel grant. So we'll cover the travel costs, of course, the entrance to the conference and accommodation. Deadline for applications is the 1st of July next year. Speaking of travel, thank you, that was not easy for me. Paul's also been a great friend. No, became a great friend. So, speaking of travel, I suppose all of you want to know where to travel next year. No? Well, I'll reveal it. There. See you all there next year. No? I can hear you. Does anybody know where this is going to be? Actually, there's a prize for the first person to guess correctly. The first person to guess the city correctly wins a USB stick. Wrong. Who said that? Congratulations, you won a USB stick.
Thank you.
The mystery person on the board to organize the Bella conference is already on the board because she's been the organizer of the Sofia conference.
Okay, so I don't have much to say. I just hope to see you guys next year, and Belgrade is great, so I hope you'll enjoy it.
And with that, we are done. Safe travels. See you all in Belgrade, I hope. Sorry. One more thing.
Oh, and I actually think I know how to do this. Right? Oh, wait, is this right? I should have had a... Do I actually need this, or do I? Okay, fine. Was that right, or did I just? Oh. And for your entertainment, I will try to put this on. I should have figured it out from the last. Right? My hair. Okay. Thank you. Yes, I'm an engineer. So I'm Deb Goodkin, if you don't know me already. I'm Executive Director with the FreeBSD Foundation. And so I'll try to keep this quick because I know people want to leave. But what we try to do in the foundation is recognize some FreeBSD contributors at various conferences. And so what we'd like to do is present some FreeBSD people, well, first recognize them, and then present them with a little gift. So first I'd like to call up Colin Percival, if he's here. I thought I saw him. Yes, there, he's way up there. So good. So these are new. So people call it being fleeced, and so the tradition continues. But we want to thank you for your efforts on the FreeBSD project, keeping me keeping the financials up to date and transparent. He's always keeping me correcting newsletters and whether we have stuff on the website. Anyway, I just said that because he just emailed me. But anyway, for his work on getting FreeBSD at Amazon on the EC2 and other contributions. So thank you. The next person we'd like to recognize is Alan Jude, who is he here? Yeah, he is here. So Alan Jude, he's one of the hosts of BSD, God, I'm really losing it. I've been here for almost 2 weeks now, so I'm getting a little tired. But BSD now, and from talking to some people here at the conference, that they got introduced to BSD and FreeBSD actually through their program that he co-hosts. So there you go. Thank you for all your work. And then the next person we'd like to recognize is Michael Dexter. And is he still here? He should be. He's right here. See, he must have known. And there you go. Thank you. So I'd like to thank you for all your advocacy and all the work that you've been doing, especially recently supporting FreeBSD. So thank you. Thank you. And so we have one left, but there's actually two we're going to represent or present this to. And one is to Paul Schenkerveld. I probably destroyed his name, but in memory of him. And what we want to do is, we appreciate all of his support, and what we wanted to do was give this to his wife. And what we're going to do is we're going to mail this separately to him, or another one that we have. And but one story that I always remember of him is sitting down, and I believe it was at Malta, and that was my first EuroBSDCon. And I talked to so many people, and many people I'd never met before. And so I'm from the U.S., and and I had the opportunity to talk to so many people from around the world, but I sat down, I was talking to him, and he said, so how is the conference going for you? And I said, well, it's great, but I am so exhausted because many people have different accents, including myself, and sometimes it's hard to understand, and we're talking very technical, and even though my background is engineering, it was an operating system, so there's a lot of features and functions of operating systems I don't understand, so I'm talking to people with strong accents and with, terms I didn't understand, so I told him how exhausting it was, and he looked at me and he said, well, just think if this was your second language and how exhausting that would be, and it made me realize, because most of the people, we're all here together, we're all speaking English, and for most of the people, it's not your first language. And so it really made me realize how appreciated just what everyone else was going through. And so anyway, that was my story of him. But the last person that we're going to recognize is Shtariana. And come on up here. For all the work that she's doing, she did an awesome job on Sophia last year, and I expect the same and more next year. So thank you. So thank you everyone.
I don't know, but I think there was a goat that was supposed to change hands. Did that occur? No, I can see it over there.
Now, some of you may not have met Groff personally. May have met Groff over the internet. Look up EuroBSDCon on Twitter. That account probably has more followers than your account does.
Put on there. Yeah, let me start again. Yeah. This one. Should be working.
Yeah. Can you hear me okay? Is this too loud? Okay. So, Groff has been to more conferences in the past year than any of you. I became Groff's escort at EuroBSDCon outside Washington and took Groff back to Media PA. If you check the Twitter account, you'll see the good time that was had there. I've brought Groff around to EuroBSDCon, and Groff's next visit is to Brazil, to the conference there. Jim is going to take Groff. Where's Jim Thompson? Rather than here. Just pass Groff back, please. And so it's a very good example of how a community mascot came about from something totally innocuous, like a lot of really great projects. If you really want the history on that, look up, it was Sean Webb. Look up his Twitter account and Google for goats. Each year at BSDCon, there is a BOF. Well, this past year was the second year we had it. There's a goat BOF on the Tuesday night before the conference starts, and that's where Groff turns up, and then it's just basically a session all night long. Thank you. Am I supposed to auction stuff off? No.
Well, Yeah, as we mentioned during the opening session, these books here have traveled the world, written in Norway, edited and printed with help from No Starch Press in California. Rod bought them and brought them back here. They are mint condition, will be signed by me and Henning at least. So who's up for? I told you to think of numbers. May I hear first bid?
What currency?
Whatever you have. Maybe Swedish krona. So, do I hear 100 Swedish krona? I have 100. Do I have 150? 150 there.
Not so fast.
200. I have 200 for Benedict. 200. Well, listen to one after this, so I won't be letting you off the hook. I have 200, 300. I have 300. I have 300. Anybody over 300? This will go to the EuroBSD Foundation, by the way, so it's a worth the cost. I have 300. 400. I have 400. Any better? 500. I have 500 from, that will be here. Do we have 500? 500?
I'll go 550 if Henning writes something really dirty in front.
No, yeah. Trust me, he will. I have 550. I have 550. 550, anyone? 550. 550. I think. I have 600. I have 600 going for 600. 600 with a dirty inscription from Henning. Yeah, well, I'll sign it afterwards. Yeah. And I have a second copy. So, what do we hear? Can we top the 600 or? What? I can't trade. No. Well, one more book of PF. What do I hear? Oh yeah. Well, don't be shy. 200. I have 200. 300. Okay. I have 300. I guess we get something dirty from Henning in this one as well, so, come on. Well,
That has to be something different, though.
yeah, well, 400. 400 for the dirty inscription for Henning. 400. 400. Pardon?
Does he also paint?
If it goes over 1,000, yes.
So still at 400 or 500? 500 for the dirty drawing from Henning. So, come on, this is turning into art. 550 for the dirty drawing.
It's only included if it goes over 1,000.
No, that's painting.
550. 550. Any else? So what else do we add? So it's 550. Is it going for 550? I think it is. 550 with a dirty drawing from Henning, and it's gone. Thank you. Also, the seriously padded clothing here.
What size?
Probably about yours. So, let's hear it, Michael.
It's never been in the snow.
Well, they do have snow in Australia?
They have snow in Australia.
Mm-hmm. Yeah. So, do I get a first bid for somewhere? You can get some seriously good clothes for a seriously small amount of money. Yeah. What?
Swedes, it's nice.
Yes.
We're naturally resistant to cold, so we don't need those.
No. Yeah, well, we thaw every now and then. Do I get a first bid? Let's see if we can. It says large.
But that's in the pounds.
Yeah, both are large. So, one set of padded jacket and pants, large, going for.
When the blizzard comes, you won't hear about it.
Yeah, 20. Come on, better. You can do better than that. Going for 20 crowns? Really? This is just everybody wants beer instead.
It's perfect for the speakers to get the bread home.
Yeah, wonderful padding for the crisp bread. That's true. So, do I hear anybody better than 20? Like, do I sell for 20? 100? I have 100. And you don't need crisp bread, do you? Or I have 100 for the set. 200 for a set. Anyone? 200, 200.
Just include the dirty boy money. If that makes the foundation more money, yes. If it makes the foundation less money, then no.
Well, come on. I have
500.
500. I have 500. Is that going to be the ending price? 500? Oh. Come on, you can do better than this. 500. More than 500. Do I have 6 somewhere? No, let you, sir. All right, looks like it's going for 500. Gone. We have some signing to do, and Jan.
I think this concludes all the 5 extras. So I wish you all a safe trip home and hope you have a really good convention this time.
satt upp så har så man inte behöver men det är bara börja plocka ner nu då.
Ja, det är inte så mycket att